Welcome, everyone. Happy Friday. Or for some of you, it's probably Saturday. But let's stick with Friday. It's the weekend nonetheless. So, yay. Okay, so what's the thing with today's stream? So, I believe it was Tuesday, we took a little piece of software that was written in Nim. I was writing it myself. And out of frustration of tooling, I ported it to C#. Now that I have it kind of finished and working the way I like it, completely restructured, changed the algorithm, everything, I figured, hey, maybe we're going to port it back from C# to Nim now that we have something that has some kind of vision, and we'll see which one's faster, if it maps nicely and whatnot. So that's the plan, but the other thing is that I'd like to take the stream from today. Hopefully we'll be able to finish the whole thing today. I would like to take this stream and then turn it into, a video where I cut out all the parts where I'm like scratching my head, why on earth isn't it working? Maybe make it shorter, like I used to some of my live streams. So yeah, that will be a test. So maybe sometimes I'll just take a pause and whatever. So I actually need to remember to hit record. Otherwise, I won't have a stream to edit. Alrighty, so maybe I'll explain a little bit of what the idea is of, what this kind of application is that I'd like to port, okay? So the whole idea is that this is something called Lead Calendar. And all you need to know is that basically it takes few people, letters number 8. So let's say it will be Bob, Dave, and Mary, okay? We just have 3 people, and then we need to schedule them in 1, 2, 3, 4. Let's say for a month, okay? So we have 4 weeks. So let's just do weeks. Okay. So we have 4 weeks, and we basically need to schedule them. So, can I put an emoji here? Yes, I can. So basically, I can say that Bob is on 1 and 3, Dave is on 4 and 1, while Mary is on 2 and 4, okay? I know it's not pretty, but whoops. But you get it, right? So we have this kind of calendar. But the thing is that it's not that simple, okay? The whole idea is that I'll be calling the persons actors, okay? So let's just add actors, okay? And we're just gonna add one more person, like, I don't know, Zoe, okay? So the actors, I don't know why, not actors, agents. That was the proper wording, okay? So we've got the agents, and we need to plan them out. So the rules are that each agent, there we go, to this kind of solution, please. Each agent must be assigned to 2 weeks, okay? And weeks must be staggered. And I'll say or considered conflicting. Okay, so let me show you what I mean. So notice how Bob is in week 1 and 3. This is 1 and 4. 2 and 3. If we would take Zoe and put her, let's say, on a week 2 and 3, we got a conflict here. They are next to each other. She shouldn't have, 2 consecutive weeks assigned. So that's one problem. But the other problem is that we also have week 0, which is the previous week from the previous assignments or something, okay? And maybe we had Dave and Zoe on that previous week, last month, let's say. Suddenly, if we assign Dave to week 1, we're going to get a conflict. So we would need to reassign him here. But there's another rule. Each week has to have at least 2 agents assigned. Okay? Least. So that means that this is wrong here. So we would need to take Zoe here, but we can't because she will be colliding. We would need to arrange her like this. So maybe like that. And now week 3 isn't right. Now it's right. Okay? So I just reassembled it and that's how it works. But there's one more thing. Sometimes an agent might decide that, you know what? I'm unavailable on I don't know, on this date. Okay? That means that we need to consider also that somebody is not available. That shifted this thing here, so wait, what? No, we need 1 extra in week 3, and we already have a problem where we can't do anything. Because if we're going to assign Zoe to week 3, we have no way to avoid conflict. Maybe not within just this thing, but, there are situations like that. So, yeah, the whole idea is that we need to find all the possible valid plans, and if there are no valid plans, we want to find like a seriously, I'm drawing and explaining and I'm not even sharing the screen. Oh no, just wasted a bunch of time. But I think nobody's watching it. At least I didn't get any complaints. So I'll just kind of explain it for the sake of the video. Okay? So the whole idea is that we have agents as in people, and we need to plan like several weeks for them. In this case, 4 weeks. But we also need to consider week 0, which is the week that we have from like the previous month. Okay? And this is because we have specific rules for assignment. Each agent must be assigned to 2 weeks. Exactly 2 weeks. So let's do exactly 2 weeks. Okay? Let's put the word on the other. Okay? So we ignore the week 0 because that's a previous period, but we always need 2. If we would have something like this, this is bad. This is not possible. And weeks must be staggered. So something like this is unacceptable. It would need to be like that. Okay? And then we have a rule where each week needs to have at least 2 agents assigned. So we don't allow for a situation where, like here, week number 3, we have only 1 person assigned. This is invalid. We would need to do, for example, something like this. And of course, we have a conflict. So this here is already a plan that seemed like it would be easy, but not really. It's not possible right now. We will need 1 more agent to do it comfortably. So that's the gist of it. And the way I solved it, let me just draw the way I solved this problem. So I'm gonna draw a box around this thing. We're gonna put it nice like that. And we're gonna name it plan, okay? This is a plan, and the background. Can we like bring it to front, please? Bring to front. There we go. So this is basically, this whole thing is a plan, as in a valid solution to our problem. So the thing is that the most basic idea would be to have something looking slightly normal. Basically a plan, right? So the idea is to find all the possible plans, all the valid solutions. So the way I started doing that initially is that we basically had a plan, okay? And I would basically, straight up copy this thing, okay? I would have this plan. I'm gonna zoom out a little bit. And I'm just gonna copy a little bit. And do more copying just to illustrate something, okay? So the whole idea I had is that, okay, we have some kind of initial starting point, right? Our initial starting point is that we have a plan that has only filled in the previous week, because that's data we have, and which are like excluded weeks for each agent, okay? So this is our starting point. And from there, we're basically picking Bob, and maybe we have two possibilities for Bob, okay? It would be probably easier for me to copy from here. So we have different possibilities for Bob. For Bob, we might have a possibility where he's assigned like this, okay? Or maybe we have a possibility that he's assigned this different way, okay? So we basically generate those two various possible plans from there. And this is like impartial plan, so this will be partial. Let's do initial state. And we have partial plan, and we have another partial plan, okay? And as we're going further, we basically define that, okay, let's start picking Dave for this variant, and these are all the possibilities of Dave. And this then would go further and further and further, okay? And we're doing that for all the possible variants, looking for possibilities. Until at some point, okay, we're gonna arrive at a full plan. Can I just grab the whole thing maybe? Until at some point we arrive basically at the whole plan. And from there we can take it as in, is it valid? Let's call it a valid plan. And that's just one of the valid plans, because as we're exploring those endless possibilities, the number of them explodes like crazy, right? Because this is just what? Not even fully first agent and then parts of the second. There are several more, and with each step it grows, I don't know, like a factorial or something. I mean, depends, because each one has different variants. So that was the first idea. But then I was like, it actually worked. But for some larger calendar, like maybe we have 10 agents and 5-week month to plan out, suddenly we have just such a massive amount of data that we are storing, because we're storing each step and all the possibilities, that even though this is like, a little tiny bits of data, it started taking up, like 70, 80 gigabytes of RAM, up to the point I need to stop before it finishes, because it was generating just hundreds of millions of those plans, okay? For a specific scenario with 11 agents, few excluded weeks and 5 weeks total. Basically, to find a decent solution was to try basically 360 million combinations. So, it's a big number. So the idea is that maybe instead of doing it the way we did that initially, we have our initial state. And what we would do is from that initial state, we would just go grab, the agents, and we would just do, something like this. Okay. We're just going to draw a box around it. And wait, not like that. What the hell am I doing? Maybe something like this, and then we would have a different one like this, and yet different solution like this. We would generate all the possible variations, okay? Of that for each agent, okay? So for each agent, we generate all the possible variants. So maybe for Bob, it was a little bit less because he has this thing that doesn't work here, so he's gonna have something like this. And they all have their thing, but maybe Zoe and Dave, they have this other conflict, and they have, therefore, here we have some extra possibility, right? So we basically pre-generate all the possible combinations that each agent can take, okay? So we're just gonna try to move it and put a label on it, okay? So that it looks nice in the diagram. So let's grab it, let's paste it, and this will be combinations per agent, okay? And the thing is that with those combinations, we can just give them IDs, right? So we could just do something like 1. And then we would have 2, right? And then we go with basically combination 3 and 4 and whatnot, okay? So we can basically number them. And therefore, our plan, instead of having something of this sort, our plan could be, let's call it plan, or like partial plan. What we would do instead is let's delete all this bunch of junk. What we would basically do is choose the combination, right? So basically, for Bob, let's say we choose the combination 1. Okay, and I'm just gonna kind of pre-make it so I can place it here. Okay, so for Bob, we selected combination 1. And this is our initial state. Okay, we should actually have for Bob, we have 2 different combinations, so we have 2 different states. Okay, and then from this point, let's just space them around a little bit. From this point, we can keep generating more plans. Okay, so those plans will be, this case for Dave, we selected either 0 or we selected 1, combination 1 or combination 2, right? Because he had 3. And the same thing would be generated from here, okay? From this initial plan. The only difference is that we just had the first combination selected was 2. So suddenly, instead of holding, all this data as we're going, we're just holding one array of, one little sequence of numbers. And that's it. And suddenly we're good. So let me just draw arrows. Okay, and from this we're going somewhere else, and and then we have a situation where, fast forward, we selected the combination was 2, 0, 3, 1, okay? And this will be a valid plan, because from here we can just reference our initial state, okay? We could just reference our initial state. Enter, yes. We can reference our initial state because that's simply, something we can just check. Okay, for Bob, wait, this actually needs to go here. For Bob, number 2 will be this combination. For Dave, will be combination 0, and so on. And this way we can, we don't have to store that much data. All we're doing, we're just exploring all the possible combinations of plans to be generated. And as we're going, we're just checking if it's possible. Because if we would generate, let's say, a plan here with combination 0, 1, and let's say 3 and 0, and at that point we can check if it's possible. So we're checking all the boxes, and might be invalid plan, okay? And invalid plan will just simply grab the X and exit. Okay? We just abandon it. And for some situations, by pre-selecting those possible combinations, we're already getting rid of some of the things, but we can finalize if everything is fine here and just discard some plans. So that's that. But then I figured out, we can optimize even further just from the concept of how much data we're storing at each step. Because at least in the land of C#, when we define an array, okay, so let's say, let's just grab a nice box, array in C#, okay, and array in C# basically has the data, okay, so A, B, C, D, and whatever. It has the data, but it also has a reference pointer, okay, because the data itself is somewhere there, but it's a reference type, therefore we point to it. So data will be, let's say, if we would say that it's int, and we have 10 integers, and that will result in 10 times 8 bytes, so it'll be 80 bytes. That's our data, but we also have the extra data, which is in our case 8 bytes because it's an int 32, okay, or probably 64. So it'll be 16 bytes? No. Sorry. 4 bytes. So we go 40 bytes here. So suddenly we're storing the reference pointer even for this one. We have int64 for the pointer, and then just one little piece of data, okay? And we're doing all that. So what if we could actually get rid of most of the data itself? So here where comes the third idea of simply saying that instead of having combination, it will be selected combination, okay? And I'll be, let's say, 1. And in this case, this will be for Bob, okay? But we don't need to store that information. We just do select the combination. And then we have the parent plan, okay? So we're just, instead of storing all the data, we just point to the previous one. So here it will be null, okay? Because we don't have a parent. But then we maybe we have variance. Therefore, he will have combination 0, he will have combination 1, but the parent plan exists. I won't be typing it here, but basically the whole idea is that the parent plan is pointing at this, and this parent plan is pointing at this. So really, all we're doing here is N64 to have that thing, and we always have just a single number for each plan. So as we get to the complete plan, it will be basically just a bunch of those that point back at each other. And when we get finally to the point where we need to verify that data, we can just get back the pointer, reference them, get the combinations to assemble the whole state of the final plan, and do stuff. And therefore, suddenly we store so much less data as we're generating those millions upon millions of possible combinations. Sure, we can add a little bit extra stuff like, was the previous plan conflicting or whatnot, and we can just extract data again baked from somewhere else. But this is where I arrived currently, and this is what I have implemented in C#. And the idea is to now turn it into basically a nice NIM program. So let's try to do that. So from the C# perspective, I have the project somewhere here. Let me just pin it to the taskbar. There we go. So program is relatively simple. The whole program is basically, here's an example of an array that I was trying to draw. But the whole idea is that we basically give the number of, in this case, I would prefer to just have it like this, okay? Just number of names. We said which names were in the previous week. We can also say which weeks are excluded for each agent. We just check for conflicts. This is purely to just print out that, hey, somebody like Harry here, he has only options of being assigned here and here, and these are conflicting because these are 2 consecutive weeks. Actually, with this one and those 2. So, yeah. We'll just point out a message. And then we're basically, what we're doing here, ignoring all the measurements and whatnot, we just have a loop. And every time in a loop, we're just go process next plan, go process and generate more plans. And we just have that loop. And at the end, we just print a bunch of stats. And then we basically assign scores and choose the one with the best score. Okay? And we'll get to how this whole find plans loop iteration works. But this is basically what I tried to draw there. It does something of that sort. So in the meantime, let's create a new project for that. I have this whole lead calendar here. So maybe what I'm going to do, maybe we're going to just make a new folder there, okay? New directory just for the NIM project. So I should be able to go to repos and lead calendar. Okay. Right now I just have the C# project here. So wait, what's going on here? There you go. A new folder. NIM version, right? Go here. And we can just do Nimble init. Okay. This will be a binary. Okay, this is just a program. Initial version of package, whatever. Description, we don't care. MIT, sure. And lowest supported version, 204. Okay, it should be good enough on that version. Okay, so we've got our project. We have our source, we have our Nimble. What I'm going to do is also grab quickly from a different project. What was it here? We had random NIM, right? We could copy VS Code and just paste it here so we have it set up. Now we right click, open in code, And I can actually close the other old one. And we should be set. Okay. Let's just make sure that this is our entry. Let's call it lead calendar. Okay. And in tasks, it should be all good, I presume. Yeah, looks good. So we just need to go source and rename it to lead calendar. That's our entry to our project. So that's that. And we can start replicating. So I'm going to put two projects side by side and let's see how it goes. I'm going to make them both a little bit smaller because, you know, I'm sure you can read it on a stream. So let's select like where we can start in both of the projects. So on the side of C#, I basically create a class planner builder. What it allows me to do is basically call a bunch of things like add agent and then set previous week and whatnot. And then when I call build, only then it creates a instance of a planner class. So we have planner builder that collects all the data in, you know, not very optimized way. And then we have the actual planner that takes all the data that was already prepared on computer, whatever, and actually has the capacity of executing code and getting to somewhere. So maybe we can try to start the planner builder, okay? Because that sounds like a good place to start. I'm gonna make that even smaller. Something like this or like that. Yeah, I'm sure you'll be able to read it. Okay, so what do we have here? How could we do? Let's make a new file. Let's call it planner builder.nim. And in our lead calendar, we can basically import planner builder. Can I do that? I can. It's just not being used, but that's good. So on our planner builder, we need to basically store a few things. Oh, another thing is I want to avoid any kind of global state. So I'll be trying to have this planner builder as an object that I can define a bunch of stuff. That object can hold all the data, and only then I'm going to actually build it. This way I would be able to, let's say, create several different planners and execute them all together, and they shouldn't be interfering with each other. That's like a just basic good practice. So let's create that type. Okay, type, we'll call it planner builder. There we go. A reference object, sure. We don't need a reference object, right? Just object. So I guess it already expects what I will be doing. It might be my AI helpers might be a little bit, remembering what I worked on before. So let's see. So the whole idea is that we have weeks count. We don't want to make it public, and that will be. So that's the thing. I'll try to do int 8. Okay, so that should be a byte. I actually should do uint 8. I'm gonna try to use all those fancy little things. Okay. How does it know that I'm doing exactly that? Well, agents per week. I don't even have it open anywhere. What? Agent names. Excluded agents weeks per agent. And it also knows it as that. IDs. What? I don't know. Okay. I don't know how it can figure that out because I have two separate IDEs open. What the hell? Okay, this is a magical AI moment I think we're experiencing right now. Yeah, I need a pending plan and I need a frozen state and state combination, edge state combinations, and the scorer and score combination. Holy moly. And add agent and add previous week and build the whole thing and generate combinations. What? I mean, all that is wrong, I'm sure, but okay, that was a crazy moment. Awesome. So let's just, this will be just a planner builder, okay? Just one thing at a time. How funny. So, okay, we're just holding the data. So we basically are holding the number of weeks that we have to assign. How many weeks are required per agent? In this case, each agent has to have exactly 2 weeks assigned to it. Then we have minimum agents per week. So each week should have at least 2 agents assigned to it. And we have agent names, which will be basically a list of names. And what's important to point out here is that those agent names, they are basically in a specific order, and everything else will follow exactly the same order. This way we don't have to do any weird table lookups or dictionaries or whatnot. Then we have a sequence of sequences of bytes. So this is basically excluded weeks per agent. So this is a sequence that basically depicts, list of agents. And for each agent, we're storing a sequence of numbers that basically say which week is excluded, okay? Something very simple. And then we have previous week agent IDs. So this is basically by agent ID, I mean which order they are, Bob was first, second was Dave, and whatnot. So basically which ones were assigned to the previous week. So this is kind of our, starting point where we describe all the information. So in C#, I have the planner builder constructor, okay? And then we don't have constructors, so we can just do something like a proc that will be new planner builder. We'll need to expose it. And what? We need to specify our weeks count, our weeks per agent, and minimum agents per week, right? All those basics we're gonna specify here. And we'll return the planner builder from that. Okay? So all we're gonna do here is basically assign them, right? So we just do result because this should already build a planner builder for us. The result is this and that and that. And then for agent names, we just make an empty sequence. The same thing for everything else. It's just empty sequences, okay? And all we're doing here is just create a new planner builder, okay? Assign the data and that's it. No big deal here. Next thing will be to have add agent defined for it, okay? So with adding agent, the whole idea is that we can pass in information about agents. So let's do proc add agent, okay? We want to call it on an existing instance of the planner builder. So we just take builder and maybe here we're gonna make it that actually reference object, okay? This way we can just reference all the copying and everything, right? Planner builder, okay? This is our, what we can call it on. And then we basically want to give an agent a name. And then we want to have a list of excluded weeks. So we could just do excluded weeks and say that it's a uint 8 sequence, okay? Something like this. Okay, and that will be it. But the thing is that that means that we need to create an array wherever we want to assign something, so we can use the more fancy, which will be our args uint8. So this is like the equivalent of params. Okay. So that will be that, and implementation of it should be pretty simple. In our builder, we want to basically add name to the agents, right? Do we have something like that? It has no type or is ambiguous. Let's ignore that. Control S to save. Yeah. Okay, now we're good. Okay. Wait. I'm not be able to assign it because expected first mismatch position, add this and that. Agent names, add, right? Name. I don't know why it's not happy about that. Am I missing something about sequences now? Because I switched to C# and suddenly I forgot everything about nim. Also builder dot excluded weeks per agent and oh yeah, you're right. Thank you, beef. Beef. Is that the elegant beef? String. That's true. Okay. Control S and it disappeared, ugly squiggly. So then we want to basically have the excluded agents weeks per agent, and we basically need to assign that. Can I do this? Excluded weeks. No, it's not liking it. I keep forgetting how to actually concatenate sequences, so I'm just this var args will basically mean that it's var args. I am not sure right now, because I could just loop over it, but I'm sure there's a better way. Can I add the whole thing? We're adding to sequence. And I could probably do something like this to turn it into a sequence. No. To sequence? What the hell am I doing? So the beef says you need to do excluded weeks per agent. This dot add excluded. Oh, of course. Yeah, I need to add the whole sequence. Yep. Let's just see if this will actually like it. But not, because this is probably not a sequence, it's var args, therefore I need to turn it into a sequence somehow. Oh, now it decided that squigglies are fine. Thank you, Beef, you're very helpful. You are actually really, really, really helpful. This is where those little annoyances come in for me in nim language, where I don't know exactly how to do things yet, so working with sequences sometimes is kind of confusing. But okay, we have this, and the whole idea is that because it's a builder, so we can use a builder pattern where each of those functions return the reference to the builder itself. Therefore, we can just return builder, okay? And therefore, we just, can chain them. And I'm not sure, but no init. Was that a proper pragma? This should prevent nim to try to generate an automatic return type for that function. I don't know if it's smart enough to just straight up ignore that, its existence. But yeah, that's something to do. So before we continue, let's try it out. Let's see if we can actually write something in our Nim calendar. Okay. So the whole thing started here where we had our planner, right? So we'll just do let planner is new planner builder, right? We're gonna specify that I want 5 weeks, 2 weeks per agent, and 2 minimum agents per week. And I think we're gonna be expecting those errors sometimes. New planner builder. We're gonna add those agents. Something tells me it'll know exactly the number of agents that we need. There we go. Just add them all. There we go. It knows everything. But we need the planner builder and the add agent. Okay. Those two things are the things that we need. So ignoring this, let's just comment them out. Let's see if I can run it, or maybe we're gonna Control Shift B. Run. Just normal run, right? Okay. Build failed. Nim version nim. Oh, I see. We're getting some little thingy here in our tasks. Is it actually expecting? Yeah, in our nim version. There we go. Ben will be lead calendar. And can we run it now? Okay, we got cannot open file. Seriously. Planner builder .nim. That shouldn't be the case. What the heck? I need to look at my previous NIM projects because I'm getting confused. How the hell was I doing imports in in other projects that required a thing? So let's say here. Oh, from planner builder import this and that. Yeah, that's the Python thing, right? Yeah. From this import. And we probably don't need this whole thing. Wait. Where's the main file here? Not here. Here in this little program. I wish I could just import the whole thing. That would be much easier rather than picking and choosing. Because I would just like to do import me this whole thing. Okay. Will that work, please? Thinking. Oh my gosh. Sorry for all the stupid things I'm doing. Okay. We arrive at the proper combination of characters. Okay. Good. We actually got somewhere. Great. And we should be able to just echo planner. What's gonna happen if we're gonna Try to do that. Nothing, right? Because we can't print that. There was a nice little function for that, for printing out the whole thing. But I'm not gonna bother with that right now. So we have the add agent. So the next thing will be to be able to set the previous week, okay? So in our planner builder, this is actually the next thing that we can define. So let's look how we can do that. So the whole idea is that we have set previous week. And again, we need to provide the builder. And the whole idea is that we let's make it easy on us. So let's just make it so that we just do, hey, so these are the names, and all we need to do is verify that these are correct names and just assign them. Figure out how to assign them in code, okay? So we'll just take those agent names again as a var args, so we can leave it empty if we need to, and we'll return the planner builder. This way we can chain even more, okay? And now, as we go here, so in C# I had a for each loop. Basically, I iterated over each name in the names that we just received, and just tried to add them, okay? So let's do for agent name and agent names, okay? This is the nicer part about NIM. We can iterate real nicely. So considering that, what were we doing inside this part? So basically, what I was doing is given the agent name, I was looking for it inside the agent names sequence to get the ID of at which index that that agent lives. So let's think. Let agent ID is, do we have find? System find returns the first index of item in a or -1 if it's not found. Cool. There we go. We're just gonna find the index of the first name. And therefore, if agent ID is -1, it's exactly the same thing like in C#, we can just raise a new exception, whatever. I don't remember if that's how you raise it, but NIM doesn't complain about it. So all we want to do in that case is just throw something, hey, we don't like it, and that's it. What happened here? I want nice indents. What the hell's going on with those indents? Strange things happen. Okay, so that's that. And if we actually have a valid name, then what we can do is basically go to our previous week's agent IDs and just add that ID there, that, hey, this is one of our agents that is excluded. I mean, that is in the previous week. So, yep, previous agent IDs we just add, and the important thing, we need to convert it back to uint8, I presume, because if we're gonna do agent ID, previous agent IDs has no type. Previous week agents, jeez, that's what I get when you tab the AI completions. So previous week builder dot previous week agents, add, and our agent ID. And at this point, it should complain that one is this, the other is that, and we just need to do .uint8, and that should fix it. Yes, because remember, this is an integer here that find returns so that we can have that negative value. So that's pretty much it. We had the same conversion here, so it's actually funny how exactly the same this thing is. So after we go over all the agent names that we received, we can just return the builder and call it a day. So now, magically, this should be fine. So we just went through the easy part. Now the little bit more difficult part will be actually, building the thing, because that's a little bit more involved. But we should get there, right? We'll get there. So in our planner builder, I have basically the build thing. And the build thing, it's relatively short, but involves a bunch of other stuff. So that's going to be fun. We can take it one step at a time, okay? So let's make the proc build, okay? And we give it a builder, but the whole idea is that we return a planner. So what I'm going to do is quickly go and create a new file, planner.nym. And we're just going to define type planner. And planner will be also a ref object because it's going to be quite large. And I know, let's say that for now it just says weeks count and that's it. Okay. That's all we have here. So now our planner builder, we just need to import it. So import planner, and that should be it, hopefully. Okay. See, we can return a planner. Cool. So yeah, let's start going through those motions one by one. So on C# side, I basically, what I did is I created combinations per agent. And this is basically, how do I define it? Combinations per agent. So this is a list of state combinations, of an array of state combinations. So let's take it from the state combinations. So we're going to pause it here. I'm just going to add a quick return planner and whatever. Okay. This is just a placeholder. So let's look at the state combination. So what the state combination is basically equivalent of this little box here, where we have, let's say, Bob, and we know that this is a valid combination for him to have in a calendar, or this kind of valid combination. Okay, that's all that is. Therefore, what we're storing in that state combination is basically the week selections. This is just an array of bools, which is true or false for each week. Is this week assigned in this combination or not? And additionally, we have has conflict. This is just so we can, precompile, bake in that information here that, hey, this combination is the one with a conflict where we have 2 weeks, consecutive. Therefore, might not be the best choice, but in some situations is unavoidable. That's why we're not discarding it here. And I'll ignore the whole printing because we don't need it right now. So maybe we're just going to make that little state combination because we will be using it throughout. So let's make a new file, state combination.nym. So we have type, state combination, and this will be not a reference object because this is a little tiny thing that it will never ever be modified after we create it. Therefore, it just stays here, okay? So what we're going to do here, all the fields will be public so that we can access them easily. So we'll have the week selections, okay? And those week selections will be basically a sequence of Boolean types, okay? Just check boxes. That's what we can imagine as. And then basically if it has conflict, true or false, and that's it, okay? So let's just have it like that. And we're gonna go back to our lead calendar, planner builder. This is gonna get busy soon enough. And we can import it. Okay, state combination. Those names will be a little bit confusing at times, but oh well. Okay, so in our planner builder, we can finally make that list, and name it will be a sequences of state combinations. Okay, so we're just gonna do for combinations per agent, and that will be basically a new sequence. Sure. No, let's define this type. The sequence is it's a sequence of state combination. And why is it a sequence? Because state combination is just one possible combination for an agent. Therefore, each agent has a number of combinations. And then we have many agents, so we have this whole thing. So yeah, not the most readable thing, but it works. And then the additional optimization thing is that I want to keep something called first conflict indexes. So when we will be generating those combinations for each agent, we'll arrange them in a way that in the beginning of the list, we'll have all the like valid perfect combinations, and all the kind of conflicting ones, the ones that are not too optimal, that we would prefer to avoid, will be at the end of the list. Therefore, we can basically define that we want to have, this would be var, and this would be var as well. First conflict indexes. So basically, for each agent, we'll specify which index in the combinations per agent thingy, which is the first combination that's actually the conflicting ones, the bad one. So therefore, when we have situations where we found at least one plan that's valid without any conflicts in it, we'll be able to just start completely ignoring all the further conflicts, because if we have something with conflict, that means it will be instantly worse than the plan that we found. Okay, so this another optimization. A lot went into that. I have a few live streams before that, how I was going through that process. So next thing, we have for loop, where we'll be iterating basically over every single agent. And what we're going to do here is, what the hell are we doing here? A comment will be helpful. We create we generate a list of state combinations for that specific agent, okay? And from that, we'll basically return a tuple of the state combination and what is the ID of that first conflicting one, okay? And then we'll basically add them to those sequences. So that's it, something simple. So, and to iterate over all the agents, so we basically go over agent ID. So we know they start at 0, and we can basically grab them for the builder from agent names, because we know that at the point we call build, we already have all the agents added to the list by add agent, add agent, whatever. And therefore, we should be good at that point. So yeah, so it'll be nice. It clearly knows the code I have selected on the right side. What the hell is going on? I really don't understand that. Because I'm using, instead of using Copilot, I'm using SuperMaven. And using model adapted to lead calendar. And what about here? This one doesn't say anything, so I don't know, it's just magical. I kind of love it. That opens new possibilities of just, hey, we're porting AIs on our side. So the whole idea is that we return the state combinations and the first conflict ID. And we just call the generate state combinations that we don't have yet. And we pass in not all that. All we're going to pass in is just the agent ID. That's all we should really worry about. Generate it for that agent and take it from here. So let's go and define it, okay? Generate state combinations is red, a little bit lower here. And this will force us to again, get more code, like calculate initial state, get empty weeks, and generate combinations, whatnot. So this is gonna be fun. So Because, okay, now we're encountering that one thing that I don't like about NIM the most, which is the fact that if I want to use something inside build, it needs to be defined before that. So, I don't like that part. So I guess I need to just go here and define a proc, which won't be exported. It will be just generate combinations or state combinations. And it just takes an agent ID as an UInt. And what it returns is gonna return a tuple. Okay. It's gonna return a tuple that holds a list of those state combinations for that agent and the ID of the first conflicting one. Okay. So what we're doing here, so the way this works here is basically, let's look through the C# code. So first thing we're doing is we're getting a list of empty weeks. So we can get an agent and, hey, list me all the weeks that are empty. And this will be just IDs of those weeks. So we'll return, let's say, list 1, 3, 4, which means the week 1, 3, and 4 will be empty. And again, week number 0 is the week prior to you know, the previous week from the previous month. Okay. So yeah, that will be the thing. When we generate it, we can just do let empty weeks is just get empty weeks from the agent, and therefore we need to define it again. Proc get empty weeks, and that will be just a sequence of bytes. Okay, let's get there. And what do we have here? To get those empty weeks, we basically need to get the excluded weeks per agent. So for that specific agent, we just get the let excluded weeks. We just grab it from here. That should be fine. Oh, that's right. This is the thing that kind of sucks. We need to specify that this is the builder, planner builder, and therefore we can call it. And because of that, we need to call it with builder.thing, and this needs a builder as well. Builder, planner, builder. Okay. We just need to keep doing that everywhere. So this one will be also builder.generate state. Okay, we're moving forward. So get empty weeks, we get the excluded weeks, okay, for that specific agent, so we're good with that. Next thing is we basically create a new sequence that will be for our, you know, I kind of prefer doing this. Okay, I kind of prefer this setup. Okay, so we've got the empty weeks. This is where we'll be adding the week numbers. And all we need to do is basically iterate over all the possible weeks that there are, skipping the number 0, and basically checking if they are within the excluded weeks. And if yes, we just add it. So for week from 1 to builder weeks count including. So basically, what can we do here? If the excluded weeks, do we have something that contains here? Yes, we have contains. Awesome. Contains the week index. Can I force the week index to be uint 8? Or not really? I guess I can't force it. That's too bad. I would like to iterate over something else, but oh well. We can force it like this, and basically, if it contains it, If the excluded week is excluded, we basically skip it because it's not empty. We want to return empty weeks, okay? And otherwise, we just add the week there and the week index again. And that should be it. At the end, we just return the empty weeks. But what do we have here? Contains the discard. Type mismatch. Huh? Why do we have alloc here? Where did that come from? Not alloc I. U and 8. Weird. Very, very, very strange. And so, yeah, if that works, that's good. And this, for some reason, doesn't work. Empty weeks, we have sequence of U and 8. Therefore, that should be absolutely fine. Sequence of U and 8 and U and 8. But that's why we have add. Should compile, in my opinion. Okay, so yeah, that should be fine. Mutable. Oh yes, thank you, Beef. So good that you're watching. Yeah, so it'll be fun if it didn't say that it's a like type mismatch. If it would should say that mutability mismatch or something, that will help save me so many hours of just scratching my head and getting annoyed. Yeah, that the compiler like errors are not great, at least in my opinion, compared to a few other languages where they nicely show you here this and that and try to figure out. Try to help you. That's what I like. So we've got that, and that's good. So we've got our empty weeks. Okay, that's the first step. Then we want to, as we're generating the state combinations, we have our empty weeks. We can start generating the action combinations. So the idea is that we have some kind of combination helper. I think I'll be able to just copy paste it from a different project because I already wrote it initially in NEM, so I could just reuse it here. So basically, the generate combinations, it will work in a way that we give it a list of just numbers or like any kind of items and how long sequences of those items we want, and it would generate all the possible combinations of those items that we give it. So it will be just a generic thing. So yeah, that's it. And Beef says that it does say in the later procedure mismatches that expression is immutable, not var, but sorting does not just put those forward. Okay, so I guess I'll need to scroll somewhere further. I'll learn it eventually. Alrighty. So let me grab that other project that I opened temporarily. And we should have some combinations. Yes, that's the code that I made at some point. So let's copy it. I'll explain it real quickly. And let's just make it into... let's call it new file. Combination helper. Okay. I won't be capitalizing anything here. I'll just keep everything lowercase. I don't know why, but whatever. So the whole idea of this little procedure is, or function in this case, is that it's generic. So it takes any kind of type. We give it items, a list of items, and a length. Length is basically how long sequences we want to have. And the whole idea is here that it basically calculates all possible combinations of items with specified length. So if we give it 1, 2, and 3, and set it we want to sequences of 2, it will go exactly 1, 2, 1, 3, and 2, 3. So it won't generate like 2, 3, and then 3, 2, because that's basically the same thing. It's just unique combinations of those. Sorting doesn't matter. Okay? So, yeah, it just makes a list of combinations, preps items to be actually accessible, because there's some weird quirks with us specifying another procedure here. It kind of doesn't like accessing stuff from up there. And yeah, the way we generate it is basically for each item, we create new combination with that item added, and we basically check if it's the proper length, we add it to the list. If it's less, we call it generate to add new combinations, and that's it. If it's longer, we don't generate more. And we just start it and go. That's it. So this code, I remember, it works pretty well. So we should be able to go to Planner Builder. Again, import it. Auto imports will be nice too. Okay, so we have that. We were building here. So we can say that combinations. This will be, I think we can do let combinations. We'll see. We'll have more cryptic errors if we want. So calc combinations, and we just need to give it the possible numbers. In this case, it'll be IDs of weeks that are empty. So it'll be empty weeks. Empty weeks. Okay. And builder weeks per agent. We have that value, I believe. So that will be basically, each agent needs to have 2 weeks assigned only. Therefore, we create only 2 item combinations. We could just change it up there in a builder at some point, when we're creating new builder, that we want to have 3 week-long assignments, and it will just properly generate different length combinations. So we've got that step. Let's move forward. So just having the combinations possible for each agent, that's great. That helps a lot. But it would be nicer to just, because every time we make plans and whatever, every time we need to apply that week to the initial state, we can just pre-calculate that. So let's let state combinations. Okay. And this will be basically a list of, that will be a sequence of the state combination. So this will save us some time, and this will be just that, okay? And the way we can calculate them is we need an initial state and then apply those combinations to it. So yeah, so in my C# code, I have straight up initial state, right? So let's create that initial state. At some point I thought maybe it would be worth saving it, but not really. So that will be calculate initial state. Okay, so we'll just do builder calculate initial state, and we need to again write this thing. So another proc, calculate initial state. And what does it require if we control click it? It just should require the agent ID and return a sequence of it should return a sequence of Boolean values, and this will be the initial state for the particular agent. Okay, and so let's see. So basically what we're gonna do here, we're gonna check if this agent is in the previous week. If it is, that will be the first element of our list. Okay. Wait. Oh yeah, we do that, and then we create a list that has the correct number of weeks, and we just do that. So let's do that. So we have let is in previous week, and this will be basically builder dot previous week agent IDs, and we just check if it contains our agent ID. And I don't think we need to convert it here. We already have it as int 8, okay? So this will tell us if it's in a previous week, and then we're gonna create a nice state for the thingy. And now, because this is a sequence of booleans, can we specify the number? We should have some like new sequence, right? New sequence. Create a new sequence of type with the length of that much. And know that the sequence will be filled with zeroed entries. For boolean, it will be a false, okay? So new sequence, it should infer it, and we want basically a number of builder.weeks count, how many weeks we have. And we want extra one, that's 0 week, and this would be basically our empty list, okay? And do we need to specify as bool? I guess we do. Okay, so this will be our placeholder state, and the first week is of course true or false depending if it's in the previous week. In previous week, that looks better. Okay, and that's our initial state. That's all we're doing, because initially everything is blank slate. We don't worry about marking that, okay, this week is excluded, this week is that, and that, and that. That's why we're generating those combinations that will be applied to there. Therefore, those excluded weeks will be skipped. But initially, we just have empty state, just if it's true or false or whatever the first week. That's all we care about. So yeah, little helper function abstracts it away, and therefore we can when generating state for that specific agent, we can have initial state. Okay. So what's next? So if we have initial state defined, we can basically check first conflict index. Oh, that's the next thing that we need to start doing. So first conflict index will be 0. Initially, there is no elements, no conflict, so whatever, 0. And then we can do a little bit of clever, looping. So we're just gonna go over all the combinations that we got from the combination generator. Okay. And what we're gonna do here is we're gonna basically get the state combination. So add state combination. So what I'm calling here as combinations is basically combinations that could be applied to a state. And state combination is basically already pre-calculated state for if that combination happened. Kind of. The only thing that we have extra is that first week, but it still matters. There's still a big difference, okay? So what would happen here is basically I would need to do that initial state dot apply combination, and we just apply it. Okay, that's how I would like to be able to call it. So that's what I'm gonna do. But let me just fast forward a little bit. The idea here is that we calculate that combination, and then because the state combination will be this whole type of state combination that has the element that says if there's a conflict. So if that state combination has a conflict, we basically add it at the end of the list of those state combinations. Okay. While if it's not there, if it's not conflict, we insert it at the beginning, right? Whatever that will be at index 0, right? We insert it at the beginning of the list and increase the first conflict index. So kind of that index, we put an element to the bottom of the list, and it shifts the index up or down or whatever you would call it, however you would imagine it. So that's the clever part. And that'll be all to it. Let me just, after the loop, I'm just gonna quickly do that. We're gonna return basically the list of state combinations and that first conflict index. That's what we're gonna return. Now we just need to implement the apply combination. Now we can apply the combination to the initial state. So I would like to basically, because apply combination exists somewhere here, do we need to utilize knowledge from the builder? That's the question. Because if not, we could just, define it somewhere else. State, so to apply combination, we just basically clone the initial state because that's what I needed to do in C#. We shouldn't need to do that in NIM because assignment is basically copying of sequences. We go over each combination, and for that week, we basically mark it as true. And then we're just gonna call the detect conflict. This is another little helper function. And this way we'll have basically precalculated if there's a conflict for that specific state and return it. So that's gonna be real simple. And I can see that nowhere here we need access to the builder, okay? I wonder why it doesn't want to mark it as static. That conflict, if I make it this static. Oh, it takes weeks count, that's why. It needs the total weeks count. But we can just specify it, right? This way we will have it nicer. So let's do it that way. We're gonna go to our state combination, okay? We're gonna specify something called proc and detect conflict, okay? And what it needs to receive is basically a state, which will be a sequence of booleans, okay? So that's that. And do we actually need that? Check each week if it has conflict with previous week. I don't think we actually need the week count because the length of the state already tells us how many weeks there are. Good. All better for us. Look at that, even knows the exact comment. Wow. So the way we can check it is basically we take the first this week before the week before the month, the last week. So the previous week, we just take it out of the state, okay? And this way we can start a loop where we'll basically iterate over, and not each week in state. No, we're gonna over week, I'll call it week ID, okay? And from 1 to the state length. Without the length actually included there, okay? So we'll basically iterate over all the weeks, but excluding the first one, because we already assigned it here. And to find 2 consecutive weeks, we could just check if this week that we're iterating over, if it's set to true, and if the previous week is also, okay? So we could actually swap those, make this check first, and the access to the array later. This way it's sliver of performance more, I presume, unless compiler is smart enough to flip it itself. Don't know. So if basically we have that both are set to true, we know there's a conflict, and we don't care more. We just return true as there is a conflict, okay? Otherwise, we just keep iterating. We just need to remember to assign the current week to the previous week, as we'll be increasing after that. And if there's no problems, we just return false, okay? So it's deceptively simple. What did I just turn on? No idea. Go away. Weird VS Code shortcuts. Alrighty, so that's good. So now we can go on to do the apply combination. So again, this is pretty simple. Proc apply combination. So what we're gonna do here with apply combination, we need to give it the initial state. So we'll just do an. We should be able to call it on the state combination. Wait a minute, how do I want to use it? Initial state. I'll call it on the initial state. So it'll be initial state, which will be a sequence of those booleans. Which will be just first week true or false, and the rest will be all falses. And then the next item after that we're giving it is the combination that we selected, which is again a sequence of bytes in this case. Combination, which will be a sequence of bytes. Okay. And the combination is basically a sequence of bytes because we have numbers of which week. It could be, let's say, week 2 and 4. Okay. And we want to return the actual state, which will be the sequence of booleans. Okay. So let's do that. So the thing is that I don't think we need to do that because in C# I needed to explicitly clone the array that was the initial state. Okay. But in this case, we could just do state is initial state, and that already does the copy. Okay. And this way we have it mutable because we don't want to mutate this one. So, we have nice and mutable array. And then what we can do is basically go over each combination, each element in the combination, but each element in the combination is basically the ID of the week. Okay. So then we just check if set that state of that week ID is basically true because it's in the sequence, right? Everything else will be false. So by applying, we're basically adding to the existing thing, and that's all we're doing. That's it. And the other thing is that we just need to mark if has conflict, and now we detect the conflict from the state. We should actually be able to just do the state.detect conflict. A little bit nicer. And we just return the new state combination. Let's just see what it requires there. Not that. State combination. Weak selections will be state, right? How the hell do you do it? With this? No. How do I create the other place? When we created the planner. Oh, with column. Okay. Yeah, and C# will be equals, and that's it. So it has conflict, this has conflict, and that should be it. But because I misspecified here, it should be state combination. Again, that's a object, not a reference object. Okay, we did some gymnastics. Gosh, this is going way slower than I expected, but at the same time, I'm astonished how one-to-one it translates from C#. It's just, wow, okay. I guess the difference would be in case I start doing weird class stuff. That's where it would differ. Okay, so let's just close those up. We won't need to touch a combination helper anymore. So in our planner builder, we were working on the generate combinations, okay? So let's get back there. Generate combinations. So, okay, we went over those. All that is already implemented. And then we return a tuple of state combinations and the first conflict index. So what doesn't it like? State combinations. Da, 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 da. Implementation of planner builder, da, 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 builder, planner builder, agent. Expected. There's no implementation? Really? Okay. That's a new one. And where's our build? What we're doing build? Return planner. Let's try to run it, okay? Well, if we'll go to lead calendar, we have this, and we can try to build. Oh, look at that. Beef comes with help. I'm feeling watched now. Tuple AB is for the named tuples. Oh, right. That was another thing. I think I encountered that problem before. So we have A and B, right? Okay. So I would actually like to name them. So this will be the state combinations. Okay. And this one will be the first conflict index. A little bit unsightly, but I don't feel like defining just a special type just for that thing. And therefore, we're gonna, I mean, this should kind of fit in, but I'm gonna specify it anyway. State combinations and this thing. Million errors. Okay. So let's compile it and see what's an actual error, because I simply don't trust nimsuggest. Ambiguous call both system AUINT iterated declared system. Oh wow. Planner builder name 42. Okay. Ambiguous call both system AUINT 32 iterator and system uint 64 iterator are declared, and there's a match for uint 8. So let's do dot uint 32. Will that fix our problem? That's very interesting that those iterators are not defined for all the types, huh? So try to compile. What other error we're gonna get? Planner builder 5640. Okay, type mismatch. So let's see. Calculate combinations. Where did we define it? Oh, we probably didn't specify the type, right? Type is uint 8. Will that fix some of the issues? Let's try to see if we're gonna get a different error. Not really. Declared routine sequence, we're gonna get there. So this is an error or warning. Looks like a warning. Well, here, to sequence. Huh. And float. Not sure what you mean with int and float, beef. Interesting. So let me look at the combinations helper. It expects length and int. Oh, I see. So let's actually fix that, and let's make it uint 8, because this will never be anything higher. Okay, that was a reference to anonymous tuples. Okay. So let me just see where I'm using length, just to make sure that we're not getting more weird stuff. It doesn't like that for some reason. Will you like that? No idea. But where am I doing length? Show me the length. There we go. If this equals the length. So now we can compare. Oof. Int, presume. No. Or maybe. Okay, let's just build it and see what we're gonna get. Okay. So here, 1230. Okay, type mismatch. So on the left side we have int. So yeah, we should be able to just do .int. Just like I expected. .int. And let's build it and see what happens. So, okay. Different kind of error. Planner builder 6330. Type mismatch. So state combinations add. On the left side we have this, on the right side that. So I guess state combinations need to be var. Okay, there we go. You Control S and everything goes red. Let's see. Now we have. Okay, we're moving forward in the file. Okay, type mismatch got integer for first conflict index, but we're expecting the int 8. So we define this. Let's define as int uint 8. Okay. And where else do we doing? We're just increasing it, so we can just do inc. Okay, and that'll be it. And that should make it work, hopefully. I'm sure there are more errors. Of course there are. Type mismatch. This is really good for a stream. Watching a guy go through a million errors. But that's my experience with Nim so far. For some reason. It's just, I don't know. I guess my initial super excitement went away for some reason. Okay, so now we have a mismatch somewhere here where we're trying to extract it. Type mismatch. Planner builder and then agent ID. That's what I passed in, right? Planner builder and agent ID. Tuple of state combinations and first conflict and 8. Agent and 8. Agent ID, there we go. Dot and 8. The number here at the start of a mismatch shows the position of mismatch. Okay, that's a position. Oh, okay. So it's that's very helpful. So in those error logs, we have, the thing that we provided. We provided generate combinations, and we provided number 1 planner builder, number 2 integer. While it expects at the position number 2 right here, that's where the mismatch is, this. And yep, that's very helpful. And 2 and 8, U and 8 don't match. And I missed the U. Okay, cool. It'll be fun to just do U8. That'll be even more fun. I guess one could just define it themselves. Okay, let's try to build it again. Will it work? Hey, illegal storage access. What? Attempt to read from nil. Spot 16. Huh? That's an interesting one. Most recent call. Lead calendar. Set previous week. Okay. Huh. Welcome to your first Arc bug. Okay, Arc, I presume, is the garbage collection thing or memory management thing, something like that. ARC, something counter, reference counter, as I recall. Okay. So why on earth do we have a bug here? You seem to be familiar with that kind of bug, Beef, so maybe you could elaborate, because I'm not sure where to start, to be honest. Other than go diving on GitHub for issues. Nym declare reference is last. Could be usage of no init. Okay, it's not in this specific one. So that's an interesting one. Because everywhere else we're returning explicitly this. Let me just try return. And we're just gonna do that. I'm gonna try to build with that. That'll be my first try, but no. So let's try to get rid of all no init. We had only 2 of them. And oh, that worked. I guess no init is dangerous. Okay, now we know. Don't use no init. Cool. I'll trust the compiler that compiler would just remove that. So yeah, that's that. Cool. Thank you. And with that many problems, I will probably be at that point an hour later and on the verge of giving up. Alrighty, so we've got to that point. We'll ignore all the squiggly lines. And we'll just continue moving things forward, okay? So we just finished our generate state combinations, and that's a big deal, in my opinion. So we can just take that out, calculate initial state, we have that done, this is done, this is done. We're just gonna hide all those things that we already implemented, so it's a little bit easier to look through, like set previous week or all those things, okay? So the only thing that we are still continuing working on the planner build. So we finished at the point where we basically generated all the state combinations for each agent, right? Because we're iterating for all the agents and generate the combinations. So now all we have to do is basically combinations per agent, add the state combinations, and then add the conflict IDs here. And we don't need to convert them because we already have them as uint8. So that's awesome. And so the next thing will be agent state combinations. Ha. So, okay, this is gonna be fun. So because we use select statement, so we can go into the whole fun thing of link and mapping over things, okay? So the idea here is that we have an agent state combinations. So what that is, it was probably somewhere here, right? Oh, it's not here actually. So the whole idea about agent state combinations is that we can define the type of it. The type of it should be agent state combinations. Oh, I actually define a new type of agent state combination, which is a list of state combinations. Yeah. Simply a container for set of state combinations. So why do I have call it agent state combinations? Oh yeah, because each state combinations of an agent. Okay. Because each combination has a specific... Okay. Sorry, I got confused myself. So let's do that quickly. We could probably just go to our already existing state combination and just add the type here, okay? This way we won't have to jump around too much. Agent state combinations. And that will be an object. Do we want to be an object? Yes, let's make it just an object, at least for now. And what? Combinations, sequence of combinations. And that's literally it. Okay, no big deal here. So we've got that, and we can define that our agent state combinations will be actually a sequence of agent state combinations. Oof. So that'll be a lot of stuff. So now let's look at how we're actually building that in C#, okay? Because let's understand that. So we build it by taking the combinations per agent, okay? So this is our basically list of those things. And all we're doing here is just wrapping them, all those sets of combinations, into that specific, what would you call it? Wrapper. And that's it. So kind of pointless, but the whole idea is that we just have them a little bit more wrapped nicely, so we know that, okay, these are all the combinations for the agent, and it's a little bit easier to comprehend it. So I'm gonna replicate that, okay? So select is a little bit like map in JavaScript, so I believe it's also map in NIM. Okay, so we can probably just do it here. I really wonder sometime how wrapping works, because I haven't done C# in a long time. I mean, Python, and I guess wrapping will work like a Python. We can check that in a while. So here we just grab the combinations per agent, and we should be able to do map it as in map an item. And that's like a macro where we can just use the it as an item as a little placeholder for the code that we're going to execute, okay? So we want to create a new agent state combinations, okay? And that will be that the combinations is, and that's going to be the item, right? The sequence of state combinations, right? It, there we go. And that should return a sequence, I guess, that map it. That's what I would expect, at least, that it's going to return a sequence. Let's try to build it and see what kind of error we get. Invalid indentation. Oof, that's a good one. It's the one I hate the most, I think. Got this one here. Second one that goes here. And why do I have a third one here? Now should be proper number of parentheses. Let's rebuild it. and attempted to call undeclared routine map it. Okay, so sometimes this map it works. Oh, I see. We need to import standard sequence utilities. Okay, I think that was it. Build it again. And it built it. Okay, that's good. So that works. So what's next? So after that in C# we simply return a new planner. So we just build a planner, okay? So right now we don't have the planner defined yet. I'm just gonna shove the data here the way it's supposed to work, okay? So the first thing that we need to provide is basically the weeks count will be from here. Weeks per agent and minimum agents per week. We just need to pass those on. Then we need to pass in the agent names. We don't need to change anything because it's sequence, just like, you know, in C# we basically have lists and arrays that work differently a little bit. So there's a bunch of those conversions and iterations which slow things down a little bit. And then agent state combinations, we just return those. I'll just need to check how they're named in a second. And first conflict indexes, we just pass a list like that too. So let's get to our planner, and I just want to check how I named things, because we just give things here. Oh, see? So we actually can't do that. We just need to call new planner because we need to define our own constructor for it, okay? So we're gonna do it this, and this is agent names. Then we're gonna have combinations per agent, and yeah, so everything looks good here, okay? So this will be our code. It just doesn't work yet. So yeah, let's move on to the planner. Wow, we're going fast. We have the builder done. A little bit faster than I expected, or maybe slower. I don't know. It's 12:30, so I'm talking for 2 hours already somehow. Not sure how. Okay, so we had our planner done, right? Okay, our lovely little planner. So planner will have some of the data similar to what we had in the planner builder, but not everything. So let's copy a bunch of stuff. Weeks count, weeks per agent, and agent names, all that stays the same, okay? The differences will start from now. So we have those, right? And then we are storing the combinations per agent, okay? Combinations per agent, which is that sequence of agent state combinations. And for that, we basically, fix using compile, what the hell? What is it gonna do? Declare define discard. Funny. Compile has no idea about anything here. So import state combination, as far as I remember, okay? States combination. Or no, actually state combination. There we go. So we got that, and then we'll have something called score, but I'm just gonna, for now, just comment it out. It'll be score. That'll be just to keep score. I mean, to be able to count scores, whatever. We might actually approach it differently. And then we have actually way more to hold here. We need to hold our first conflict indexes, so that we already have defined. And then the more fun part begins, because it will be regarding of how we're actually calculating all the plans, how we're actually making them. So it will be basically a list of pending valid plans and conflicting plans. So these are the ones that are not completed yet, that we just have scheduled for, to go over in next iterations, and also a list of fully completed valid plans and fully completed conflicting plans. Okay, so we just keep them separate again, and that's my way of finding optimizations. So let's just define those. We don't have those two types yet, but we're gonna get there soon enough. So it'll be pending valid plans. That will be a sequence of pending plans. Okay, we'll have also conflicting plans, and then we're gonna have valid and conflicting plans, and that will be a frozen state. So interesting, right? Frozen state and pending plan. We'll get there in a second. Let me just go over the stats, which will be total plans count and invalid plans count. I'm just keeping track of them. And then at some point it will be something called resulting plans. Okay, that's just for later, for when we'll be scoring and stuff. So that's basically what we'll be doing here. And no, resulting plan was actually won't be here because that's a property that calculates. So it's not state. Cool. So now let's talk about pending plan and frozen plan. So a pending plan is the plan that's not completed yet. And the way I defined it is that a pending plan is basically a next combination to be selected and a link to a previous frozen state. So you can imagine that a pending plan is basically some kind of frozen state and a selected combination. Well, what the frozen state is basically linked to the previous state. So that's what what I was trying to describe here. That we basically have instead of parent plan, I would need to basically call it, a frozen state that points to the previous one, and we can just hop back as we're generating the plan. Therefore, this frozen state only holds one letter, one number of the sequence for the agent that it represents. So the combination ID. And then additionally, it has a byte of states count, just so we can track how deep it is. And this helps in calculations a little bit without jumping back. This way, we keep increasing that. And therefore, at some point, we get to the point like, okay, this plan is finished. We could probably even do some more optimizations here. And of course, has conflicts, so we can keep track if the plan as we're generating it has conflicts or not. We could check each agent if this has conflicts without even getting in, grab and searching for the combination itself. And then additionally, we keep track of selections per week, which is basically, for week 1, how many agents are assigned. For week 2, how many agents are assigned. Therefore, when we get to the last one, we can just check if they're all at least 2, then it's valid plan. If some of the weeks have less, we could just instantly just discard it and, hey, this is an invalid plan. Let's not even bother saving it or performing any other checks. So let's define the frozen state quickly. So we're just gonna do right-click new file, frozen state. .nym type frozen state. There we go, and it's a reference object, and that's on purpose because we want to just keep pointing to the old ones, and this way, holding the previous state simply uses one pointer, which is what N32, so 8 bytes, and at the same time, as we're generating this massive number of combinations, we kind of keep reusing them because, again, just like here, we have some kind of frozen state here. This one points to the old one. This one points to the old one and to the old one. So basically, even though we have probably just whole trees of, growing of all those possible states, they all point to, reuse them. At the point we get to, like hundreds of millions of them, we suddenly actually saved a lot of data. I believe implementing that changed from, I actually have it somewhere here. We changed it from self-referencing frozen state from 42 to 30 gigabytes. It's just, 12 gigabytes of data of RAM less. Actually got it down to 150 megabytes when it's running, so but that's with a little other clever trick. All right, so our reference object, frozen state. What do we have here? So we have the parent frozen state. I wonder how will that work with empty references. I guess we'll get to that because I'm not sure right now if we need to hold the value there or we can just have a nil, because we're not doing exactly pointers. It's a reference type, so I wonder if reference type should already start with an arrow, right? Okay, so that should work. What else do we have? Bytes, yes, last state combination ID, states count, and again, we can use uint8 because we're not gonna have a massive number of agents. 255 of them is way more than we're ever gonna use. Check if it has conflicts, and then it will be basically selections per week. And that won't be a sequence of booleans, that will be a sequence of uint8. Okay. That's it. That's our frozen state. And I'm also gonna, let's have it in a separate one, okay? We'll keep things nice and separate. Pending plan dot nym. Type pending plan. Again, pending plan will be a reference object? I don't think so. Pending plan, because we're not gonna share it anywhere. That will be just an object. So let's get to our pending plan here. See, it's a struct in C#, so it's a value object. Therefore, object in nym. And we're gonna have basically the frozen state, a link to it, and a reference to it, and a select the combination that we're gonna apply, build the next plan for. Okay, so that'll be that. And yeah, we've got our pending plan. So let's get back to our planner. We just need to, our pending plan needs to import the frozen state. Okay. While our planner needs to import both frozen state and pending plan. Okay. Okay, no squigglies. Look at that. Pretty. Cool. So yeah, let's move forward. We got pending plan, we got frozen state, all that stuff. We've got everything done here so far. Okay. So let's move on to the constructor of the planner, because it still does quite a lot here, actually, of the preparation of the data. So yeah, we need to define it. Proc new planner. And we need to provide it with weeks count, weeks per agent, minimum agents per week, agent names, combinations per agent, and that'll be, yes, that's correct. And first conflict indexes, and that's it. And it's gonna return an instance of a planner. Okay. Can I just make them like this? Because I would really like to just do this. That's what I'm used to. But I don't know if this syntax allows for it. It should, right? Discord? Whatever. Let me skip that music. This is ridiculous. What the hell is that? Cool. Alrighty. So what is happening when we build a planner? The first thing that I'm basically doing is verifying if the state that we're passing into it is actually correct. This way I know that we're not gonna get some bad data to start with, okay? So verify agent state combinations, okay? So what we're doing here, basically, if number of agent names is not the same as combinations per agent, that means, we have a mismatch already, okay? Then we have if number of agent names is different than the conflict indexes. Again, this thing should match. And I'll skip the part where I'm going into each combination per agent and checking if they have enough, blah, blah, blah. It's kind of a little bit too much, in my opinion. Yeah. Let's just leave it at that. Next one will be to save the data that we passed to it, right? So we're actually not gonna save it, right? Because we need to create an object at the end. So let's just kind of start doing it here, where we set the data, okay? Weeks count, weeks, all that, agent names. Do we have combinations per agent? Yes, and we also have this. So all those will be saved here, okay? Let me just move the score somewhere to the end because it's related to the end. Okay? And that'll be saving the data. We'll just have it at the end. But then we also need to generate the first possible plans. Okay? Because when we start the planner, we want to just start executing like, hey, look for next plan, look for a plan, look for a plan, iterations. But we need to have some kind of plan to start with. And, a constructor could be a good spot. This way we don't have to worry about calling init or whatnot. So let's do generate first possible plans, okay? So the idea is that we basically go through all the combinations of the first agent. So how did I implement on C# side? So we basically do for combination ID, okay? And we start from 0 to we get the combinations per agent. We take the first agent that we have available and just go to its combinations and length. So basically number of combinations for that specific agent. Okay, we just iterate over that. We need to remember the combination ID here is int, which kind of sucks, but we'll live with that. So, and here I'm basically building a new plan, and then build a new plan that has new frozen state and select the combinations. And then we're going basically deciding a combination. Okay, checking if it has conflict to decide to which list to add it to. Okay. So yeah, let's do that. So let new plan is pending plan. And we're gonna do the spending plan. The frozen state will be actually new frozen state weeks count because we'll make a little constructor for it. And select combinations will be just combination ID, and that's it. Okay, because we want the next combination to be calculated that. So that's that. And before we continue, let's just do and decide. So let's get the combination itself. So combinations per agent, 0 combinations, and the combination ID. Okay. Yeah, that should be fine. That's the combination, state combination. And then if not, if it doesn't have a conflict, we just add it to the valid plan. Okay. Pending valid plans is no type. Oh, because we don't have it specified here yet, right? The pending valid plans. We just need to create it. I mean, one thing would be to just have the planner and modify it, but maybe we're gonna do that, okay? Let's do it like this. We're just gonna have the save data here. And we're just gonna var planner is this thing, okay? And therefore, we can just do planner dot pending valid plans, add, and do this stuff. Okay, pending valid plans, they're not exposed or anything. I should actually expose a few things. Things like weeks counts, this, that. These are all should be exposed. And names, combinations per agent, I did too. That, I guess, valid and conflicting. I made everything public? No, these two are not. Okay. And yeah, nothing else is public. I mean, exported. Okay, good enough. So if it's not, if it doesn't have a conflict, add it to valid plans, else add it to conflicting plans. Okay. And where was I? Here. Okay. And we also want to increase the planner total class count. Do I have total plans count? Yes, I have. It just doesn't like it. So type end and has to be used or discarded. Oh, INC. There we go. So all we need now is the new frozen state defined on the frozen state. So sure, proc new frozen state. And we just give it the weeks count. So let's look at that, at the constructor. So here I have actually two constructors defined on the C# side of things. So for the first one, we give it just weeks count, okay? And from there, it basically does return frozen state. The parent frozen state is nil. Initially, the first one doesn't have the parent, okay? Then the initial state combination is 0. We don't care about it. It doesn't exist yet. The same thing. There are no state counts. And has conflicts? No, because there's nothing selected yet. And selections per week will be basically new array of bytes. Okay? And we just create a specific number of them there. And that should be it. Okay? That's it. We just populate this, make sure that there's enough selections per week. And that's that. Let's not worry about the other one yet. Or maybe we're gonna do that. Why not? So we have another proc. Oh no, that's append state. That's not a constructor. Sorry. So we have only one constructor. Good. Perfect. We construct only the first one. Whew. Okay. So we go back to our planner. And all that works. Okay, and we just return the planner. That's that. We just created the whole thing. New frozen state needs to be exported probably, right? It is. Weeks count.uint8. There we go. So let's try to build it and see what happens. Error type expected. 83. return new planner. Huh? Oh, wait. Planner builder. Oh, I guess I just need to import the planner itself, right? I'm importing planner. So new planner is exported. What is going on? Tab expect. 2 messages have been suppressed. Bum 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 bum. Looks like beef disappeared, so I'm left alone. I'll figure it out. Okay. Return new planner and all that. So that worked before. Kind of. And we specify that it returns a planner. Okay. And we import the planner. And in the planner itself, we have defined new planner that returns a planner. And we actually return a planner. So what the hell? Type expected. Does it? No, we're doing that before. What the hell? What am I missing? Hmm. Type expected. That's it. This is so confusing. Do we do let planner is all that and then return it? Where we'll get an error now. Again, type expected. 83. What? Object constructor needs an object type. It's of type planner. Okay. So am I missing something? Did I add something to the planner? Let's put them side by side. Let's see what's going on. New planner. Weeks count. Yes. Builder.weeks count. And weeks count we hold as event date. So these types should be all good. Weeks per agent, minimum agents per week. Good. Agent names, it's here. Combinations per agent. So agent state combinations, it's a sequence of those guys. So that's good. And then first conflict indexes. It's a sequence of uint 8. And that's it. So not sure what the issue is now. Proc new planner, right? That's good. We define all those types on it and return, specify that it returns a planner. What is going on? Copy, paste. It's the same name. Oh, of course. Because this, we initially had it as construct new object. This is calling a method, so we don't need those here. Okay. Save, build, run. All worked. Okay. Okay. We've got somewhere. Now, how on earth could I print out the whole object? Because I would like to inspect what's inside the object. Its state and all its substates. Let's ask ChatGPT. Maybe ChatGPT is gonna help. Let's go to NimMaster. How can I print out all the contents of the object in Nim automatically? By object, I mean a complex type containing various fields of various types. Okay. Because I think there was something to just print it out. What the hell? Why are you trying to use Python to go over? What? What happened to the master? Edit GPT. Don't use code interpreter, okay? You have NimDocs document. Stay on the task. Jeez. Okay. Missing triple quotes here. Very strange. Update. Let's copy my question because this is getting a little bit annoying. It's like the whole thing stopped working properly. Type traits. Find macro. What? Seriously? Nope, that's not a way to do it. Oh, that's kind of ridiculous at that point. I guess we'll trust things are correct, okay? We're copying an existing working solution after all, right? Wait, what am I trying to do? Not this guy. I am trying to put this guy here. There we go. We can even do it that way. So continuing, we went through creation of the new planner. Okay, we have the whole constructor defined. We can sure print stats. Why not? That's always fun. Proc print stats. Okay, we just on our files of planner, and what will we have? Total. We have invalid, conflicting plans, and valid plans. We just print those out, and then in a new line, we basically print out how many we have in progress, how many conflicting we have in progress, and that's it. That's all there is to print stats. So that's fun. And next we have. So yeah, at this point we can start building out our program a little bit more. Okay, so let's go to the lead calendar. Okay, And in lead calendar, we just defined all this stuff. So let's see what else are we doing here. So I define basically how many iterations per message. I make like a little period on, like, besides just the loop, how often to print out the status of how things are going. So let's do constant iterations per message. And I just set it as 1,000,000, okay? And I can just do that to make it pretty. I won't be doing stopwatches here. I'm not doing measurements of time yet. We're gonna get to that later. I just wanted working first. So next thing is that we need to keep track of an iteration. So I'm just gonna do var iteration 0. We just start at 0. Then basically if we have finished, and we just do a while loop, okay? While not has finished, okay? And we do our stuff. You use 4 spaces here, please. Okay. Don't know where 2 came from. That's that. And what next? We could actually include the planner. Import planner. Okay. So in our loop, before our loop, okay, we'll just do Discord for now. We just have has finished. True, okay. We're just gonna do that and echo finished after that many iterations. Okay, we're just gonna do that. For now, it's just so that we can run it and see if it even works. Error. Redefinition of planner. Previous declaration. Look at that. If we imported it as a name planner, we can't use it here. That's not fun. I wonder if we can just not use it. No, we'll need to use it. So let's rename it to something else. The planner. How ridiculous. So now that we have the planner, the thing is that it will be nice to do check has unavoidable conflicts. That's our first try to see if things actually work correctly. Okay? So we can go to our planner and we're gonna implement the check unavoidable conflicts. So let's do proc check has unavoidable conflicts. So it just takes the planner and it's gonna return a boolean, okay? I'm not using the boolean for now, but it will return it at some point. Or let's just ignore it for now, okay? It's pointless. So what we're gonna do here is the whole idea is that we go through all the agents and check all their combinations. And if we have an agent that all of its combinations, all its state combinations for that agent, all of them are conflicts, we basically want to notify early on that, hey, one of the agents has conflicts, therefore we don't have a possibility where we're basically skipping a bunch of possibilities just because, we found a valid plan. Basically, there will be no valid plan if we have a one agent, at least one agent that has only conflicting combinations. So that's that. So let's think how we can implement that. I mean, how we can copy it. So we're basically gonna make a list of conflicting agent names. I'll be adding to it, okay? So that we can print out which agents are the problematic ones. So let's do var conflicting agent names, and it's just gonna be an empty sequence of those names. And what we can do then is basically start going over all the agents. So we have agent ID, and we go basically all their IDs. I need some water. Alrighty. I can continue talking. Let me just check something. Okay, cool. So, we go over all the agents. I even have things where we're checking things that's actually very useful. I call checking agent, and we just print out which agent we're checking. And then for that agent, we get basically its combinations. Let agent state combinations. We go to the planner, combinations per agent, and we just grab the one with the same agent ID. And what we can do then is basically iterate over all those combinations and just print out. Has the combination and then the combination. And this is where that little to print on the combination will come in handy. So let's go there quickly. Combination will be... What is a combination here? State combination. State combination. And we can just add a little fancy proc. And that'll be the $sign on the state combination, okay? So that we can actually print it out. Can I just go there? How do I define it? So we basically join the string of all the things. Okay, sure. So it'll be return. Combination, weak selections. Yeah. I would like to do it differently. So we're gonna import standard, and this will be string utils. This way we'll be able to join the string. Okay. So what we're gonna do here is basically, if we have state combination, we have access to weak sections. Okay, selections. So we'll do combination dot weak selections. And I guess we need to also get the sequence utilities, where we're gonna map it. And basically here we're doing little, if item is true, then we're gonna do X as in we have something there. And if not, we're just gonna put an empty box, okay? And then after we have all them as a sequence, we should be able to just join them with spaces. And just put a space and at the end, and if it has a conflict, we just should display if it's conflict or not. So, and I would do something like a combination dot has conflict, be space conf, else is nothing. Ah, it's so ugly. And I don't even know if it's gonna work. We're gonna see if it works. But yeah, that's where you can do the fun little operators. So that's awesome. So given that, we can get back to our planner where we were implementing this, and therefore echoing should work now. Okay. So let's continue. So basically for each combination, we're going to print that out, and yeah, we just print them out. But what I was doing here in C# is basically go over those combinations, okay? And if all of them have conflict, you basically do has conflicts only. So let's see if we can do something similar. Let has conflicts only is agent state combinations dot combinations, and we have something like all iterator has conflict. That would be interesting if that worked, but I am not expecting that to work. Well, let's check the docs, because I'm actually curious about those things here. Which one is nym? Nym docs. Let's go to standard library. And we should be able to find collections. No. Sequence utils. Okay. We have all, where we can provide it with a predicate. Okay. Iterates through a container and checks if every item fulfills the predicate. But something tells me we have a macro right now. Okay, we have iterators and macros. All iterator. Okay, there is one like that. Okay. Iterates through a container and checks if every item fulfills the predicate. Unlike all proc, the predicate needs to be an expression using the it variable for testing. Like all it, and we just give it this and give it that. Okay, so we could basically take numbers and say all it, this and that. So in our case, we could just do, yeah, if it has conflict. That should be correct. But for some reason here it shows an error. Oh, because we just don't have iterators here. Import standard and sequence utils. Okay. And it should calm down now. Okay. Infer that it's a bool. Awesome. Okay, I'm starting to like those little iterators. This is fun. I really like that macro. Because you don't need to make those lambda functions and whatnot. So that's cool. So if has those conflicts only, okay, then we're gonna basically do conflicting agent names. Okay, we're just gonna add the agent name. Okay, so we could just do let agent name. Okay, and why bother with all that? Here you go. Here's the agent name. And here's the agent name. There we go. A little bit nicer now. Cool. So we've got that, and that's our first part. We iterate over everything. And now the next part is if basically conflicting agent names, if we have any, I mean, if it's, if it's 0, we basically say no, nothing detected, else we're just gonna print them out. Okay, so unavoidable conflict detected for agents, and we can just do new things, or no, just like that. Okay, and whoa, string join, where did that come from? I guess from C#. String utils sequence utils, awesome. And we're just gonna do conflicting agent names, join, and we're just gonna combine them with this. And will that work? How do we do it in here? So join, right? It's a sequence. Should work in my opinion. String utils and sequence utils. Build it and run it. Oh, it worked. Okay. Although not correctly. Oops. Okay, we've got our first problems. Now I'll be actually finishing soon, as I need to finally get some good rest on the weekend. But let's start looking what the problem is. So we started and we check Bob and everyone, and at the end it says unavoidable conflicts for agents and lists out all of them. And that's because it prints out that, hey, there's a conflict here, but all those are empty. What the hell? We're doing something wrong with generating the combinations, unless we're not going over the combinations correctly, because they shouldn't be all the same. Okay, and we have 1, 2, 3, 4, 5 weeks. That's good. And the week before, so that's good. And it says all of them are selected as well, like they're all selected for the initial week, which is false. So let's just check if this check is even doing things correctly, because we never know. So yeah, we go over the agents, we get their IDs, so that's fine. And name and whatnot. The combinations, we go and grab them from the agent. Okay, so that's good. And then we grab the combination from the one that we just got. Cool. And we go over those iterations. So yeah. Why do I... Oh, okay, I see. Let's do this. Let combinations. Okay, and we'll just do that. A little less to read. Okay, so for me, this code looks fine. So let's see. So we could probably just inject a little bit of here and there. So let's go all the way to the beginning where we do things initially. So we can go to the planner builder and let's just print out some stuff. So we have add agent, all that stuff. Looks like we added agents properly, so we shouldn't have a problem with that. So we should go to the build. And what I would like to do is, let's see. We create the combinations per agent and all that, get it ready, then we iterate all over all the agents. This looks correct. And then we basically generate state combinations. So what I would like to do is put a little bit of debug here, okay? Let's call it debug, okay? And what we're gonna do is echo generating combinations for agent and its name, okay? And then basically for each combination that we got from there, right? State combination, I should be able to just print the combination out, right? So let's do that. Let's try to just print them out as we are generating them. What's gonna happen? Okay, let's go up. Look at that. Generating combinations for agent, this and that, and they're all wrong. So that means we're not generating them correctly. So let's look. Builder generate state combinations and the agent ID. So we give it the agent ID. So that's good, right? So generate state combinations. There's the agent ID. And we expect to return all that. So agent ID, what do? We grab empty weeks and okay. So echo empty weeks for agent name, and then we print out empty weeks. I guess I could print out a sequence, right? So they should be all empty or like a bunch of them empty. Let's see what happens. Bum, 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 bum. We're not printing out anything? What just happened? Let me just go to the planner and turn off, the lead counter and just turn that off for now, okay? Because it just adds lots of noise. Let me run it again. So there we go. We have the empty weeks. You can scroll up and empty weeks for Bob. Bob should, for Anne. Because Anne has 1 and 3 excluded. So it should be empty weeks for Anne. 1 is not there. Good. 2, 3, 4, 5. So that's good. Okay, looks like these are being generated correctly. So we can get rid of that part at least. Okay. Now what's next? Combinations. There we go. That might be where the problem is. Although, that'll be surprising to be honest, because that worked before. Vladwa says hello on YouTube. Hello to you too. How are you doing? My usual question is it night or is it morning for you? Okay, so we've got combinations. Echo. Calculate the combinations for the agent, and we can just go over them and just print them out, right? Each combination is who knows what. Nim is confused itself. Oh, look at that. No, combinations are good. This and that and that and that. That's good. Then we have a little bit less 2s and okay. Combinations are generated properly. So again, this box is checked off. Cool. State combinations. We just create them empty. Initial state. So let's make sure initial state is fine for each agent. Initial state for agent. This is that. And let's run it. For it's 8 a.m. Okay, so yeah, I guess you're my regular crowd because I have time. You know, I'm here. I'm in the US, and I basically the only time I have is when my wife goes to sleep, and I'm after work and everything, and I can start streaming 10, 11 p.m. till like 2 a.m. So nobody in the US is watching me. Everyone in Europe or in Asia is watching me, or even Australia. So that's fun. So do you program in Nim, or you're just checking out the Nim language, or maybe you're a C sharper? Which one? Okay, so initial state, we have a bunch of falses. False. Who did we have set for being in a previous week? David. So let's see. Harry, also Harry, right? So Harry, okay, shows true. So again, this step is fine. Alrighty. So we know this is fine. First conflict index, and then we basically generate the combinations. So this is where we're getting the error. So for each combination, we are supposed to apply the combination. Okay. So let's do echo. Let's just do something like this. Applying combination. To state will be initial state. Yeah, so let's do combination plus. Well, let's actually do this. Initial state, right? Initial state, and then we're gonna print plus. Gosh, so weird. And then we have the combination. Then we're just gonna make a nice arrow. Then we have state combination. So I would like to echo that. Yeah, let's see if that works. Okay, you're a Pythonista. Pythonista? Not sure how to pronounce it. But I know C# a little bit. Okay, so you're in an interesting spot. We're dealing with Nim, which looks a little bit like Python, but not really. It probably looks like scary Python. And we're moving a program that I initially wrote in Nim, then ported to C# and rewrote it in C#, and now I'm porting it back to Nim. So yeah, that's fun. Ha, look at that. It completely ignores. It takes our initial state, like all the falses, and here even if we have true or false, no matter what, it always prints out the same thing. So our apply combination, that's what the problem is. Initial state. Yeah, we take initial state and apply the combination. So this is the apply combination? Yeah. So what is the problem here? Hello, Drunken. Pythonista is like a coffee barista. Yep. Looking from at the name of your name, Vladwa, it sounds like you might be from a little bit Slavic areas, and I infer from that Pythonista, it comes from, well, like Pythonista, and you would have pianista, like a pianist, pianista, and Pythonista, person that does Python. Cool. So much in that little word. Okay, so let's figure out why this apply combination doesn't work. We take the initial state and the combination. And I'm going to open up the C# equivalent of it, the one that actually works. Bam. Where do you have it? Apply state. Planner builder. and we were doing generate state combinations, and here we had the apply combination. Okay, so let's compare them. So in C#, we create a state, a copy of the initial state. Okay, so that's good. Then we're going basically combination week and combination. And that should be the ID of the week, okay? So, look at that, combination length. Duh. So that should be more like it. And combination should be uint 8, so we just go over those, and now it should work. Let's try now. Oh, now it works. Oh, beautiful. Yep, everything works now. Awesome. That's nice problem solving. Okay, so we got to that. Now let's clean up after we were testing a bunch of stuff. This can be removed. And do we have it somewhere else? Previous week? No. No more echoes here, right? Generating combinations for agent. Yeah, we're not doing that either. We have it working now. So in the lead calendar, we can turn this back on and run it and see if it all works. Okay, so checking agent N, and we can see, I can make it a little bit larger, I believe, because this is the part that I actually enjoy. So for that agent, we can see, and agent, in this case, the person, we can see that the first week is always off, which is good, and then we just generated some variance. So for N, we know that week 1 and 3 is unavailable, so the only combinations are here. And this one has 2 consecutive weeks, so it's marked as conflict. So that's great. And for Bob, we have similar. And notice that we have the thing where in the beginning of the list, we have non-conflicting, like the valid combinations, and then we have the conflicting ones. So yeah, this works as intended. We have everything pre-calculated correctly. So as you can see, there's a lot of combinations to like permutate over at each step. So yeah, that's why it sometimes takes a long time. Alrighty. So we got to the point where we have the conflicts, and at the end we properly detected that Harry has a conflict. Okay, because if we go to Harry, where the hell is Harry? Yeah, he has only one possible combination. I have it here. Harry basically has only those 2 empty boxes, therefore it makes this big conflict. But if we would make Harry, like, remove the number 5 from excluded and run it again, it should be like, it's fine. Yeah, no unavoidable conflict detected, and they should have like probably 2 or 3 combinations. There we go. Perfect. All right. Awesome. So we got that working. So that means that we actually can start moving on to what's happening after that, because we have the conflicts checked. We have started prepping the loop. Okay. Where's our loop? Why is it all like weird and flat? What's wrong with my code? Finished. Oh, I closed it up for some reason. Okay. So if our while loop, we started finding it here. I'm not adding any measurements right now, but what we can do is basically, what we have here is this limit plans. We can just kind of include that here, but not yet. Okay, so let's do if iteration mod iterations per message, okay, is 0. So in our case, every millionth iteration, we're gonna I'm gonna just do the planner. The planner dot limit plans. This is a little thingy that took me from 30 gigabytes of RAM usage down to 150 megabytes. But that's gonna be implementable later. For now, it will just cause some trouble. So that's that. And yeah, this iteration here first is for no reason. I could actually move it down here. Okay. I could actually do, yeah, something like that. Yep. Cool. So what matters here is that, you know, we have this iteration and we can actually do the planner print stats. Okay. Just to print the stats, and that should be fine because that's what is happening here. And we could also print out, you know, like iteration number, whatnot, as we're going through things. So that's that part. And we also need to remember to increase the iteration as we're going. And other than that, the has finished is basically set as, in this case, the inverse of find plans loop iteration. Great name, right? Let's keep that stupid name, doesn't matter. Yeah, so the whole idea here is that basically every loop we're gonna kind of iterate over the, like, calculate next plan. So let's look into that find plans, okay? It's a lengthy one, okay? It's a lengthy one, but in NIM it'll be much shorter, okay? So let's do that. Planner. And on the bottom, we're just gonna add one more proc. And let's do find plans loop iteration. Sorry, it'll take the planner and return a boolean. And basically, yeah, I don't remember which value was what. It returns false if there are no more iterations to take. There we go. We can just put that here. And finds valid plans and updates the internal state, okay? That's all there is to it. So what's going on here, we'll basically start by get next plan. So get next plan will basically take a plan from a list, okay? But it's actually a little bit more involved. Not crazy involved, but a little bit more. Very little. So we do proc get next plan. And we take the planner, and what we'll return is a pending plan, okay? So what is happening here is that if the planner, if we have any pending valid plans, we want to return that one, okay? And my code here in C# is basically go to the list, grab it, you know, like the last one, remove the last one, and do that. The nice thing about NIM is we can just do return planner dot pending valid plans pop. Okay, that's it. We should just pop it, and this will return the last element and remove it, just like just as if it was a stack. So yeah, that's why it's a little bit shorter. On the other hand, if we have a situation where we have pending conflicting plan, okay, we just return that one, okay? And then we return nil if it's not possible. But the thing here is that we can't return null, because pending plan is an object, not a reference object. Therefore, it can be nil. Only reference objects can be nil. So to fight that, we could make it optional, I guess. Deal with an option. Sure, why not? Let's do that. So we're gonna import also options, I think. Okay, which one are we not using? String utils, we're not using anymore. No, we're using string utils. String utils. We're not using the sequence utils. Cool. No, we're using them too. What the hell? There goes nim suggests wrong thing. So we should have option pending plan, I presume. Yep, and we can well, we have to look up how to use it. I keep forgetting. So this is core algorithms, collections, options, okay? An example of that is option and yep, some I or none. Okay, some or none. So in our case, return some and this and some and this. Well, this will be none of pending plan, right? Yeah, there we go. Save. That should be our get next plan. So the whole idea is that when we call get next plan and we get, none in return, that means that there are no more plans anymore. We give up on the whole thing. Alrighty, so let's continue with our C# thing because that works. And in our C# can get back to get next plan. And basically, if it's no, then oh well. Okay. And how are we checking that? Because that's another thing that this whole option, it's kind of wonky for checking. Is some and get, then is good. Okay. So, but I recall using nil somewhere. Nil. So present as nil. Non-t is represented as nil. Okay, so we should be able to just compare to nil, right? Option type, it converts nil to none and whatnot. Let's see if that works, okay? So get the next plan. For plan result is basically planner get next plan. And okay, that's actually pretty simple. Yeah, I don't think we can do that nil thing easily. Gosh, I recall seeing it somewhere. But I don't remember now. Maybe that was something with errors or something. Can't remember. Oh well, so we basically want to get the plan. If it's all good, we basically do that. Come on. Stop suggesting. Let plan is this. Okay, so we're good. Next thing that we need to do is basically start advancing the state of the plan. Okay. So we just get the agent ID. So let agent ID is plan frozen state states count. So how does that work? So we grab our plan, which is probably partial at this point. We get its frozen state, which basically has the list of the, like what's the last combination that was used. But it also has the count of the states total, how long the chain is. And we know that we start from the agent 0, then go to 1 and 2 and 3. So as we proceed through agents from left to right, we just increase it and it's being held in this spot basically, and this will be our agent ID. This is what we get by keeping the order of agents at all times. So then we basically, what we're doing is trying to get a new state, because the plan, the pending plan, has the frozen status in the previous state, but also the next pre-selected kind of combination that's supposed to happen. So we can apply that combination and kind of complete that version of the state. So we do let new state is, and this in this case it will be best to just do plan.frozen state, and we call append state, and this will take at some point a selected combination, which state we want to apply, and we just need to pass it things like the available combinations for that agent. That specific combinations actually. So we go combinations per agent, we select the agent, and from its combinations we choose this one. Oof. So remember, this is pre-selected, like pre-computed, this whole thing. So apply state should be relatively simple. So let's look what the append state is. I defined it on frozen state. So let's go to frozen state, and we're gonna do the same thing. Proc append state. So sure, self will be frozen state. Okay. Let's do parent state. Okay. And then we give it things like state combination ID, uint8 of course, and basically the new state that we want to apply. And we're going to return another frozen state. So this is basically where we're just wrapping the state in the frozen state with inside a new one. So yeah, just return it. Parent frozen state will be this, and what else do we have? Last combination ID, states count, just increased by 1. And if there's conflicts, this is basically where more interesting stuff will start happening. We need to import state combination. Yeah. Import state combination. Okay. So we're doing this, and we have the parent has conflict. So if the parent has conflict, or this new one has conflict, if either of them has conflict, it will mark it as that. This way we're basically ensuring that if there's any conflict somewhere, the whole thing will be marked as that. So that's a way to propagate that. And then we have selections per week increment. Okay, so this is another interesting one. So we need to implement the increment one. So selections per week increment. So the whole idea here is that we give it the state, like the next state, basically which okay, best viewers on something. Oh well, we have somebody unhappy on Twitch channel, I guess. Alrighty, so the idea is that we take the selections per week of the parent state, which is basically week 1, 2 agents are assigned. Week 2, no agents are assigned. Week 3, 5 agents are assigned, whatever. And give it the new state, which is basically the state of next agent, which says, which days will be, which week will be selected by the agent, and we just increment those parts. So this should be relatively simple as well. I have defined it in some kind of array extensions or whatever. But I think this is like the only place we're using it. So let's just do proc increment And we're gonna do what? This will be called on selections per week, and selections per week is selections per week. Okay, that's the name of a proper name. Sequence of uint 8, and the other one will be the bool, right? So it will be week selection, or week selections. Naming isn't the best, but yeah, we're basically applying an array of bools to an array of sequences, where each bool is considered one. But the catch is that we just need to avoid the first week, okay? So we can just perform a check, or let's not perform a check. That will improve the performance if we're not checking for things, okay? So in C#, I needed to create a new array. I mean, clone the existing one. And then basically starting from 0 to the length, I was adding one, okay? And, oh, I see. So week selections don't include, week selections include the 0 week, while selections per week don't include that. So we have a little fun thing there. So basically, because this is already a copy, we can just do selections per week. We need to be var for us to modify it. So let's do var new. New selections. And that will be selections per week. So we can do basically 4. And this will be the week ID. And we go from 0 to less than length. Week selections length, right? Doesn't matter which one. And basically, if week selections and we do week ID plus 1, because we need to remember that we need to offset it by 1 because 0 is the previous week. If it's true, basically the new selections week ID just incremented, okay? And that's it. At the end, just return your selections and we're done. So we basically created a new array here. That's important. We create a new array where we don't want to modify it. We want a new one. Therefore, when we append state, we just, create a nice little copy. Although at the same time, we have a parent state, frozen state. Yeah, that's a reference. So we don't want to modify anything there. Okay, cool. Yeah. I guess that's our thing implemented, right? Yep, that should be it. Hopefully it's gonna work. So we got our append state, so we can get back to our planner and therefore have a proper new state. The only thing is that append is from, where do we define it? Frozen state. Yeah, we have frozen state, so it should be fine. Okay, we'll see. Huh. What the hell? And declare routine period. We're gonna ignore that. It might just compile and be fine, right? Yeah. Let's just do return true. Okay. And let's see if we can just run it. Or we got some errors already. Okay, fatal error. No unavoidable conflict detected. System fatal. Unhandled exception index 6, not in 0 to 5. Ah, look at that. So this will be something probably from within the append state. Do we have where it happened? Frozen state 23. Yep, this is where it happened. Huh. Oh, because we're going through length of this guy while we are supposed to be going through those. There we go. And run it again. And now it's good. I have finished after 4 iterations. Okay. Interesting. I guess it returned false by default or something. Oh, it didn't do much in those iterations yet. Just returned true over time. Oh, returned false when it ran out of stuff. Okay, that's perfect. It's good with me. So what's next? We've got our, our plan. I mean, we have the new state of the plan, so that's good. So what we could do next is basically check if the plan is finished. And if it's finished, do stuff with it. So, yeah, if agent ID is the same as the number of agents, okay? So basically, consider that it starts from 0. So basically, we took the agent ID from how long the frozen state is, right? So if it matches the number of agents, that means that we just complete the full plan, okay? Therefore, we can check it. And we're gonna call it plan is finished, add to the appropriate list. So first thing, we detect invalid plans by verifying. God, it copied from the other one, just the whole... I'm still amazed by having 2 different IDEs and AI is aware of stuff in both of them. Like, what? Still don't understand it. And translates from C# to NIM automatically. So what? So detect invalid plans by verify state week-wise. So we have that additional little rule that each week has to have assigned at least 2 agents. Okay? So before we can mark that, okay, we completed this whole, we found valid path of combinations to get to the end, and we found valid or maybe conflicting plan, we actually need to check if all those weeks are fine. And that's why we were incrementing those numbers of agents per week so that we can check it now quickly. So what we can do here is basically for week ID n, and we basically go from 0 to this new state selections per week length. Okay, so we go through all the weeks in those selections, and basically if selections per week is larger than minimum agents per week, what? Then we continue. Okay, we just skip that part, right? What's going on? New state, selections per week. Yeah, that should be fine. So that's that. But if that wasn't the case, if we had a case where it's less, that means it's invalid. So we just do increment invalid plans count and just return true, because we just stopped verifying that plan. We can just skip it. We just don't save it anywhere, discard it. It's gone. Remember, we popped it by calling get next plan. So it's not in a list of the ones to process anymore. That's important. Okay, so we just checked for if everything is valid. It was that simple. Just go through every week and check if we have enough agents. And next part would be to check if it has conflict. So basically, because again, this new state propagated conflict throughout the whole thing, we can just check if that's new state, it doesn't have any conflicts. We can just add it to the new plan, to the valid plans list, and continue on. Just start next iteration. But the thing is that if the plan that we found is, has conflict, the idea is that we're not just adding it to the conflict list. If we already have a single valid plan, we just want to discard it, because if we have a single valid plan, it's always better than one with a conflict. So we just completely ignore the one with conflicts, and therefore, not iterate over them in the future anymore. And we're not storing them in RAM either. So that's awesome. So we're gonna do basically if valid planner dot valid plans length is 0. So only if it's 0, as in there are no valid plans, then we're gonna add it there. Okay. And no matter what, we're just gonna return true. Okay. So go to the next iteration. So that was in case we went to the end. So that was for the plan that's finished. And now for the not finished plans, that's a bit more interesting. Yeah, we're gonna finish that quickly because we have already all the data pre-calculated. We did all the legwork. So the thing is that first, valid plans. So the plan is not finished, so let's generate the next possible plans. So now we'll be basically going over combinations for the next agent, possible combinations. And then where we're doing it is, this is lots of like copy pasted code, like 3 times, just so that first we're going just over the valid plans. Okay. So we're just gonna do let first conflict index, we just extract which is the conflict index for the next agent, so that we can go only to that index, because we know that these will be valid plans because they're in the beginning of the list, the valid combinations. So for combination ID from 0 to less than the first conflict index, all we have to do is basically, hey, the next plan, let's create a new pending plan. From the frozen state is the one that we just calculated, and the next item is just that combination ID. And that's it. That's our next plan. Shove it to the pending valid plans list. Increase our stats counter. And we call it a day. Okay? And we just iterate over them. So as we're done with the valid plans, we just keep checking, if we have any valid plans already on the list, of like the computer ones, we don't want to be searching for the invalid plans. So we can just skip iterating over the rest of the, combinations, because they will be all conflicting combinations of conflicts. So we could avoid it. So if it's that, we just skip it, return true. It's end of the what do you call it? End of the loop iteration. But if we don't have any valid plans found yet, we just need to iterate over everything. So total combinations is combinations per agent. Okay, so we basically, here what we're doing is we're just pre-calculating the end of the loop, because I think we're using it in a few spots. So let total combinations is the combinations per agent, and we get the, basically combinations of that agent that we're iterating over and how many. Okay. It's just lots of ugly stuff. So that's it. So if the agent ID, agent ID plus 1 is planner length. Okay, so full plans should be added to the valid queue. Okay, so this is another thing that I just found. A little thingy. So basically, what we're doing, we're checking if the next agent that we're working with is gonna be, you know, like if the plan that we're creating now is actually supposed to be the last plan, you know, like the complete plan with all the agents. If that's the case, we actually want to add it to the like valid queue, just so that we can check it off as soon as possible instead of just having them hanging around there. Okay. I don't remember why, but that was some priority for some reason. So basically, and we do combination ID from 0 to those total combinations. Okay. What we're gonna do here is basically, again, create the next plan. Frozen state is the same thing as always, and select the combination is the combination ID. Okay, that's all it is. We add it to the valid plans, increase the counter, and that's it. But if we have a situation, of course, after all that, return true. But if it's not any last, you know, not going to produce a completed plan, so add them to conflicting queue now. Okay, so we're just going again over we start at the first conflict index. We should have the same thing here, actually. 2 total combinations. And we just created another plan, just like before. The only thing is that we're adding it to the conflicted plans list. And we increase our counter. And this is just overall the end, so we just return true. So I'm looking at that now. We're creating that plan here just the same way as we were doing it here. Yeah, we can just... Oh no, because we need to iterate over them, so never mind. This could be wrapped in a template to just make it nicer, but this is good enough. Hey, is it? We just might have everything working now. Let's try to run it. Okay. What's the problem? Okay. Type mismatch. Okay. Probably some wrong int 8 or something here. Agent ID is this minus that dot uint. Oh, we need to just make the whole thing uint 8, right? I think it should be that. Because we have agent ID is this. Wait, what was it complaining about? Oh, agent ID is this while we're using integers, so we can compare. So we just we can actually make this to be an integer, okay? And this is gonna be a little bit nicer. So let's build it again. And declare identifier, invalid plans count. So not invalid plans count. What the heck? Oh, I have invalid plans count. Oh, I see. I see. Planner dot invalid plans count. And planner dot valid plans. Okay. And we go over valid plans. This is all good. Let's see if we got any more weird things. Oh, I made planer instead of planner. What the heck is wrong with me? Everywhere. There we go. Biggest call. Here. Okay, so let's see. Bum 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 bum. Okay, this one doesn't present it nicely, but combination ID and from here and first conflict index is probably int 8, so we just do int. Okay, that should resolve the issue. And just something tells me we have more of those. Right? Agent ID dot int. And this will be dot int. Dot int. So annoying. Okay. And finished after 511,498. Okay, so I guess it just completed. So yeah, it will be fun to just do the planner print stats, right? Let's run again. Okay, that many valid ones, 158,816 valid plans, and in progress, conflicting, all that stuff. So we might have a situation where it actually works. So let's see if we're gonna do the one that, if I'm gonna make Harry here as a conflicting, as far as I know, it should try to go over 360 million variations. So let's see if I'm gonna run it, if it's gonna start going like that. Okay, we got first million, 2 million, 3 million. Okay, that's good. So let's actually run release, because that should build a little bit faster and it should run faster. Holy moly, that is much faster than C#. The problem is it's gonna eat our RAM like crazy. Yeah, 8, 10 gigabytes. Yeah, that's going much faster, right? I wonder if it's gonna use less RAM too. And after that, we're gonna do one little trick that was gonna change how much RAM it uses from, right now it's 19 gigabytes, but down to something like 150 megabytes. Okay, I'm actually excited. Yep, it completed at the proper number of iterations. Exactly the same number. Wow, it just straight up works. Wow, okay, this is exciting. I didn't expect that. I'm gonna port the whole thing in what, 3.5 hours? While explaining everything, going slowly? That's awesome. So yeah, let's just continue, and now we can add the fun stuff. So the fun stuff would be to implement the little limit plans. So in planner, in the planner, I added limit plans, and this is a smart little thingy. For that, we'll need a score, but we're gonna get there in a second. So in our lead calendar, I commented out this limit plans. So let's go to the planner and add proc limit plans. So what we're going to do here, we're gonna give it a target count. And let me show you what it does. So basically it checks if the number of valid plans is larger than that number, if the number of like finished ones is larger than that. What I'm doing here is basically taking all those valid plans, I'm shuffling them so they're a little bit in random order. This way later in scoring, you get some variety instead of having just slightest variations of the same thing. Then I'm selecting the best possible plan based on like plan deviation score, whatever. And then just completely wiping the conflicts list because we have valid plan. We don't need to store any conflicting plans. And the same thing with pending conflicting plans. We don't even need the pending ones because, let's save ourselves some work. While if we still have some, if we didn't have, I guess, valid plans and we go through the conflicting ones, we do the same thing, shuffle and select only the, by default 1,000 best plans. So let's implement that. So if we have planner, valid plans, length, target count, we should be able to do planner dot valid plans dot shuffle. I don't know if we're going to be able to call it because that requires, I don't know. We'll see in a second. We'll get there. And then we have what? Planner valid plans is, and we're gonna do the whole score thing, okay? Valid plans, select best. Actually, I guess I implemented it here. Oh no, select best will be somewhere else. So we're just gonna do select best. And we're gonna give it the target count. And we're gonna get the score, calculate plus score. So this will be like a procedure to call. And that will be it. So we're gonna get there in a second. And then basically, if there were any conflicts, wipe them. If there were any conflicting plans, like in progress, wipe them. And then we have the same thing just for the conflicting ones. And yeah, for conflicting ones, we're calculating the whole plan score, which kind of sucks, but oh well. And that will be it. Basically, the whole idea is that every, in our case, million iterations, just reduce the number of plans to 1,000 so that we don't hold several millions in the RAM. And we're already kind of pre-selecting the best ones, so, screw the bad ones, right? Why hold them? And that actually doesn't reduce performance as much. If anything, it improves it, especially if we get to a single valid plan, because then we're just wiping all the other pending things. So now let's do the select best. So select best, it looks scary, but it's simple. So this is like a little, I don't know, a little helper for selecting things. I'm gonna include it here because why not? I don't feel like putting it somewhere else. So let's do proc select best. Okay. So what we're gonna call it on is basically a, states, or more like plans. Okay. That will be a sequence of frozen state. And then, I didn't make it. I thought I made it generic, but I guess I didn't. Okay, so basically take a list of frozen states, and we also take the target count as an integer, how many of those we want, and the score will be basically is a proc. I guess that's how I define it. And that proc takes plan as frozen state and returns an integer as a score. Okay. And from the whole hour proc, we're gonna return basically, a new sequence of frozen states. And a good thing is this frozen state is a reference type, so it's just a reference. So that's that, and we can, implement that. So what do we do here? We basically, I used a linked list here because it's a nice list that allows us to quickly add or remove stuff from the beginning or the end. Let's see if Nim has something like that. So maybe we can avoid slow sequenced stuff, right? Let's see collections. Collections. Crypt bit tree now. DQs, implementation of double-ended queue. There we go. That's what we need. It's right here. So the way we do it is we just get something turned into a DQ. And then we have add last, peak first, probably pop first, pop last. Perfect. And then we can just probably, what the hell is shrink? Removes from first element from front and from last from the back. Oh, okay. Okay, we don't need that. Okay, so DQs. Awesome. We're gonna learn something new. And Nim. DQs. What a weird name. Down. There we go. So we're just gonna define a new DQ. So var result list is basically a sequence of frozen state dot to DQ. Right? I guess I can create a sequence like that. I'm not sure. A new sequence of this of length 0. Okay. And there we go. Bam. Got our result list. We'll be keeping track of minimum score and the maximum score. Okay. So simply go through the lists, score each plan, and maintain the minimum, like the minimum number of plans. So the whole idea here is that the way we want it to work is, I can actually illustrate that because it's really easy to visualize. Where's our... There it is. Yep, it's very bright, I know. So what we can do here is we can just grab a box. So what we're doing is basically plan score. And we're gonna draw another little box. We're gonna make it like this. And this will be basically our DQ. Let's just call it best plans. There we go. Okay. There we go. So what we're doing here is, let's say that we have that many plans. Just gonna do that and maybe just 2 more. Okay. And we have that much room. We selected that we want, I don't know, 1, 2, 3, 4, 5 best plans. That's how much we want to keep. Oh, we have more. So the thing is that we're doing is basically, hey, add it here. Bam, it fits. Then we're gonna score another one and compare. Does it have score that's lesser than this thing? Because lesser score is the better score here. Yes, it has the lesser score. So what we're doing is basically add as a first element. So that's gonna shove this one here and put it here. Okay. Then we've got another one. This one is has worse score. So there's more room. Sure, go here. Oh, there's more room. Go here. And then maybe we got one extra one. That's like the best so far. It's the best so far. Yeah. So we're just going to do bam. And we fit them here. And now we can't fit anymore. If this guy isn't the best score ever, if it isn't the best score and is worse than this guy, it just goes away. We're not putting it. But if it's not the best score, but is better than this guy, we just take this one out and replace, because this one is worse now. And, you know, this guy got here, so that means we just push this one out and take all those in here. And, you know, that's how we basically manage to make sure that we have only the best scores and this one out. So that's in a nutshell. A little funny thing. So yeah, the implementation just keep of the minimum and maximum score. And now we can just do basically for each plan and the plans that we have. Just like that. We basically call the scoring function here, the one that we passed in. Thank you, Drunken. So we have this score, okay? So we should be able to just call the score, whatever it is, whatever we passed it in, and get a score, okay? So now we basically, if the score is less than the minimal score, which means this is the best score ever so far, that means that we correct our minimum score because we have new record. Then result list dot, and we have add first, just like in C#. Look at that. And we just add that plan. Sorry. Okay. And because of that, we have a little bit too many elements now. So if we have too many elements, just remove the last one. But if not, we were just, you know, we didn't have enough in the list yet. So we just keep those good scores. So that's that. And yeah, that's good. But are we supposed to do max score somehow? If score is larger than the max score. Okay, so we don't need to worry about it because first we checked if it's smaller than the minimum score. If it wasn't, then we're gonna just put it here. Also worth noting, if it's exactly the same as the minimum score, we just shove it in front anyway too, because we want to save it because we don't know if at the end there's something else. So if the score is larger than maximum score, okay, but we still have room in the list, we're gonna basically add it there, okay? And add as the last one. So I did that, and I didn't handle situation where it's in the middle. Look at that. I have missing stuff. So that will be else if, okay. So the other option would be that we have, oh, come on. So we need to implement one more, the situation where we have a score that's not less than this, but less than the max one. This way we can, not really. That's not the thing. Okay. So this is not the best option, I guess. I just saw the fault. Because if our max score is 50 and this is 49, if we're just gonna take this one out and put it here, was it guaranteed that we can decrease the max score? Or is it not? So let's say that happened. Then we got like 50 and oh, we can't fit it. Only lesser skulls will start going here, so we shouldn't really worry. Yeah, let's implement that. So basically else if score is less than max score, okay? And we already have everything. Score is larger than max score. Do this. If it is less than max score, okay, we're getting into a little bit more here because we need to keep updating the max score. So let's do it that way. If the max score is I don't like it. It's starting to hurt my brain. So basically, if here we're only checking if it's larger than max score. So everything larger, fit it if there's room, okay? And just discard the rest. But what if score is less than max score, okay? You can starting grows arms and legs. Yeah. Huh. Okay, so if it's less than max score, then if there's room for it, just add it. If there's no room for it, kick the other guy and put this one, decrease the score. Kind of. I need to run a simulation, okay? Let's run a simulation because I'm not sure if we're doing well. So let's say that I'm gonna grab all those plants, okay? We're just gonna give them some values. Let's do 25, 30, 45, 2, 19, 41, and maybe 51, and I don't know, 13. Okay? We've got our plans. And we need to also keep track of. Why is it tiny? Black, please. Minimum score. So that will be like 9999. And max score, which will be 0 initially. So the way it works is that let's start with this guy. 25. Is it larger? Is it smaller than min score? Yes. So it goes to the list. And the min score gets to 25. Then we're going to get 30. Is it less? No. Is it larger than max score? Yes. Is there a room on the list? Yes. So put it in here. And max score will be 30. Then we're gonna do. Let's actually do it like this. Let's say we had this order. So we've got 45. Okay, that was our 45 thing. So now we get to the point where we have 30. And that's the thing, yeah. So we have 30 and we want to put it in here, right? But it's not less than minimum score. It's not more than 45. But there's room, so we should allow it to go, okay? And then we're going, but you know, because it should go in a center, but it can't. So now we have things out of order. If we would just make max score to 30, suddenly we're gonna start. The queue have an arrange function. What do you mean by arrange? So let's say we do that. If we're gonna set it to 30, okay. 2 is gonna shove everything a little bit down. And my own score is 2, so nothing else is gonna be allowed there. And then 19. 19 is less than 30. So in theory, we should do this. Bam. And I guess we could actually do this. Because it's less than 30. Huh, interesting. And then we go 41. It's larger than 30. No room, go away. This is larger than 30, go away. This is less than 30. And that's so we just do this and move it to 13. Huh. So we're kind of letting some smaller value go in there. So all it would do is basically the last value, if it's smaller, just put it in there. So better than nothing. So you're saying to put the list in order. Yeah, that's the one thing I was trying to be like smarter. Let's not do that. Yeah, exactly. That's the thing that upsets me, that I still have 45 on the list while 30 is out. So I wonder, because how often would I need to rearrange the list? Because I don't want, you know, in theory I could sort the whole big thing, but that would suck. Yeah, I'm trying to think how I could just avoid resorting all the time. Because the thing is that I might have, like, you know, just bunch of 2s, and that's it. I might have bunch of other ones and whatnot. It's hard to tell. Huh, that's a non-trivial problem. So let's think about it in the background. We're gonna get to it. For now, I'm just gonna have the thing that I had before, okay? So basically, if it's less, do this. If it's more and this, do that. And that's it. We're just gonna keep it the way it was. Considering how many there are, it's not too bad. Okay, and we're gonna just ignore everything else for now. And at the end, we just return a result list. I just want to go forward and, you know, go through the reduced memory, and then after that, printing and scoring. And after that, we can just improve it by, you know, having the proper things, by proper sorting, whatever. So, okay, so this is our select best. It just applies all this stuff. Let me just search for shuffle, because I don't remember which what do you call it, which module it was in, which standard library thing. Shuffle. That was in random. Shuffle again, please. So we need to call randomize as well. Okay, so planner, add random, And where do we need to put randomize? Randomize. Where is it? Because I think we just need to call it once or something. Initialize the file, the default random number generator with seed based on random number. Only needs to be called once. Okay, so let's do that. In our planner, when we create our planner, we're just gonna go for it at the end. Okay, randomize. There you go. Okay, that's that. So now we just need the score to calculate the plan score and a bunch of this stuff. Sure. So we create a new file, score, and in our planner we're gonna import score. Import score. And therefore in our score, let's see what it looks like on the C# side. Gosh, I'm excited. We're gonna finish that. Score. Okay. All looks scary, but again, it's relatively simple. So let's do. No, these are all like constant values. Yeah, sure. So const. Conflict count multiplier and deviation multiplier and deviation average multiplier. These are little like values I have for scoring, just to make the conflicts very important, that we don't want to avoid them, deviation to be important, and slightly important for, like, you know, how much is it from the average or whatever. Okay, so do we even need anything here that has state? We're just class score. We're storing combination scores per agent and whatnot. Okay, so let's do type score, which will be a reference object. Okay, so combination scores per agent, we're just gonna store that here. Combination scores per agent. That'll be a sequence of state combination score. Great, another thing that we need to create, but it shouldn't be too bad. State combination score. I think that was like really dumb here. State combination score. We don't need that. That's stupid. I'm not even using that. What the hell? So let's not do it like this. We're just gonna store the number, okay? Because I don't have anything else in there. So that will be integer, okay? Per agent. Oh, not really. We just need to be a sequence of sequences of integer. Okay. And what else do we have here? Nothing else, I believe. Yep, that's all that we store. So we want proc new score. And that new score, we just need to give it combinations per agent. Okay, cool. And what we're gonna do here is basically do, you know, score dot combinate. Oh, we need to create new score. Okay. Return score, and basically the combination scores per agent will be calculate combination scores. That will be a static one, so I don't think I need to even have the score instance here. Calculate combination scores. Okay. That'll be it. And yeah, so let's define that. So we need to import. I've state combination. Was it state combination? Okay, so that we have this type. And we can now define a proc. This. And it just takes the combinations per agent. Okay, so let's see how is that defined. State combination score, all that. Okay. So the result will be that. We already have result defined, so we don't have to do that in nim. Then we go for each agent ID. Okay. So for agent ID, from 0 to basically length of those. Cool. Then inside that, so we do let combinations count. So basically we take that agent, number of combinations, and length. Result. Yeah, let's add. Okay, I see. So basically let's add. Oh, and we need to provide the new state, this thing. New sequence. No, we'll be just adding it, right? So we don't even need to worry about it. Combination ID, so we just go over them. Yeah, we can just keep adding, I think. Oh, no, new sequence, we'll just create them once and it will be a little bit better, faster, I guess, instead of keep increasing the thing. So new sequence is of type sequence of int and combinations count. Okay. So we've got that. And then we basically go for each combination. We just do it. And then will be score combination, which again, we need to implement. Combination agent ID, this and that. Okay, that's good. So let's actually do this first thing where we have result is a new sequence and we just calculation this per length. Yeah, let's do that. This way we're, instead of adding, we're just gonna result agent ID is this. Okay. Tiny bit nicer. So, wait, it's sequence result. New sequence of integer. Oh. Okay, more like this. Cool. Okay, I'm gonna take a short break, so I'll be right back. Okay, I'm back. So what we're doing, we went through here for all those. We'll need to implement that, and at the end, we're just gonna return. I mean, don't need to do that. Okay, cool. So now we just need to have one more score combination. So score combination. There we go. Rock score combination. And all it takes is state combination. It returns a score. Okay, cool. So we can just do this whole ugly thing. Dot score combination. That's better. Okay. God, that's so ugly. Okay, so so we're doing what we're doing here. So score combination. So the whole idea about the combination is basically how many little conflicts do we have. So if we have somebody that has a schedule of 5, let's say we have 5 of those, and we have an X here and X here, we have only 2 of them together. So we have like one conflict. But if we would have a situation like this, that means that we have double the conflict. And that can actually happen if the first, like the previous week was already scheduled, okay, while all those are unavailable. So if we are forced to schedule the person only on those 2, and therefore there will be this triple conflict or whatever. So we just need to count how many conflicts there are, and we're also supporting making, plans with where there are 3 selections required or more and whatever. So I'm just making it work for everything. So basically, if the combination that we pass to it is already marked as doesn't have a conflict, we just do return 0, okay? Because it's perfect. No penalty scores, whatever. That's the score that we're returning is basically like a penalty score. So yeah, that's interesting. So then we're going, the conflict count is 0, and we start counting. So, as previously selected, we're doing a similar thing that we did before, and basically for weeks, and we start for the week 1, not from week 0, because we already have this one in here. And then what? We're just, current selected is we just take the week, and if basically they are both marked as, if they are both marked, that means that they are next to each other, therefore there's conflict. And instead of stopping, we just keep going. And at the end, we just have the number of conflicts, right? So we can return as a score number of conflicts times the conflict count multiplier, which will basically multiply it a little bit more. Let me actually flip them. This will be nicer. Okay. So yeah, that's that. And bam, we should have at this point, when we can use score, all of the scores pre-calculated for each possible combination. So that speeds up how we can basically calculate the scores. At least part of them. Okay, so that's good. Yeah, we were able to create a score. So we need to put a spot for it here. And in our planner, we should create a new one, right? Score. Yeah. Bum 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 bum. We're creating one. We're not creating one. Planner score is new score. Yeah, this way we have it. This and that, and that should be it, right? This new score. Yep. Cool. We save both. We're good. So that is, I believe, it. Calculate combination scores. Let's see. Because for our limit plans, use calculate plan score. Ah, look at that. So we need to continue implementing things. So we have our new score. Okay. We have the constructor. Where is it? Score. Yeah. Get combination score. It's just retrieval. So proc get combination score. So we have the score, right? And we need to provide it the agent index. Why is it int? It shouldn't be int. It can be int. Why not, right? Because we're accessing it through index.dot anyway. And we also need combination ID. Okay. So then what? What we're doing, basically returning the go to this and that's that. So it's like, you know, nothing. Then calculate plan score. That's it. Proc calculate plan score. So this will be basically calculating 3 types of score. No, 2 types of score right now. So we call it a score, give it the frozen state as a plan. And what we're doing here is basically let conflict score, and we'll basically score calculate plan conflict score. Give it the plan. Okay, we don't have it yet. Then we have the deviation one. Okay, and we just add them up and return. So we can start adding them here. What is that? So we're gonna do proc calculate plan conflict score. Calculate plan conflict score. There we go. And we just give it frozen state. Do we have that already? Combination, but not plan conflict score, right? Okay. Cool. So for that, if we want to calculate the basically conflict score, all we need to do is get the state IDs, get state combination IDs from the plan. What's that? Get state combination IDs. Oh dear God. How many things did I implement? I wrote a lot of code. That's in the state extensions, but it'll be in a frozen state. Okay. So frozen state, proc get state combination IDs. Okay, so we'll give it the frozen state and we'll be able to return just bytes. So, result, we'll just make sure that it has enough room in there. Current state is state, so we copy the state. And basically, for each state count. What are we doing here? Result I is... Oh, okay, so I'm literally extracting the sequence of those combination IDs. Okay. Okay, this, that, and then we just have reverse, which is already implemented, which is nice. And we don't need to return the result. So we just do import sequence utils, I presume. Do we have something like reverse? Reverse. Thermal algorithm. Ew. It's not in sequence utils. Okay, it's an algorithm. Reverses the contents of the container A. I presume it's fast, right? Yep, so let's do algorithms. Or one algorithm. Sometimes it's options, sometimes it's algorithm, utils. Okay, so we can reverse it, and that's good because we're extracting them in the reverse order, so we need to just reverse them at the end. So states count. Okay, dot end. Cool. Alrighty. So that part, yeah, I'm slowly running out of steam. It's getting late for me. And we go here. So get state combinations IDs we have. So calculate conflict score. I'm just going for it now. So, state IDs, we don't change that, right? Yeah. So let state IDs is basically plan get stat combination IDs. Do we have it available here? No, we need to import frozen state. Okay. So the state IDs, and then we can just do score is 0, and we go for each agent. And we're just gonna go, hey, score increased by the get combination score from the scorer. And what else? Just return it. So instead of actually doing the score thing, we'll just do result. Increase the result, okay? And we passed in the score, so we should be fine. Okay, just complaining for no reason. Unless number 3 ID stat IDs. Where's good combination score? Oh, it expects int, that's why. Cool. So that's that. So yeah, that's it. Wow. 3 lines of code instead of 1, 2, 3, 4, 5. Nice. Okay, so we have just one more, which is the deviation score, which will be somewhat simple. Proc calculate what? Plan calculate. Go away. That. So yeah, we just give it a plan, and it'll be very similar. So we basically have minimum agents per week. We just did that. Maximum agents per week. Sum. And what we're doing here is basically for each week. Okay. Just gonna do if it's selected. If it's selected, we increase the sum. And if it's less than minimum agents per week, we just either increase or decrease max agents per week after that, and that's how we get min and max. And then we can basically calculate the total deviation and get its score. Wow, that's completed a lot. Basically, average. We're gonna see if that's gonna compile. It's float, so that's good. Then max agents per week minus average, all that stuff. We're gonna probably get some errors here. Then we've got max. I guess that works. And what just happened here? Average is sum divided by the number of selections per week. Okay. Deviation down is max agents per week minus average. Deviation up is average minus minimum agents. Max deviation is basically the whichever number is larger, up or down. Deviation average score is max deviation times deviation multiplier. And then the whole score is deviation score plus the deviation average score. We already did the multiplier thing. Okay. Dot int. Save. And what problems do we get here? A lot, looks like. Okay, because selected is uint or something. What is going on? Selected is uint. So let's make it into int. And that should fix the rest. Now the deviation down. Let symbol require an initialization. I did that, but it should be fine. Yeah, because other than that, there's nothing else to do here. Let's try to compile and see what happens. Validation, score 36. Oh, we didn't close this guy. Then we have 61. So we get int and average. Okay. I mean int and float, and it's not happy about that. So we're gonna basically do float. And this dot float. Okay, that should fix some things. Okay, figured out those. Good. Okay, now we go back to planner. Remove last. Okay, apparently there's no remove last. So let's look at the DQ again. Add first. Let's see, it'll be DQs here, right? So we have add last, and let's see what else do we have here. Clear contains init, len, peak, pop. We could do pop last. Yeah, and just ignore the thing. So we do pop last and discard. Let's try again. Mismatch. Got DQ. Well, was expecting a sequence. Yeah, 2 sequence. Okay. Undeclared field, calculate plan score. Okay, we still don't have that or something? What's going on? In our planner, and the limit plans, calculate. Wait, limit plans. Ah, look at that. Calculate plan deviation score. Well, the other one will be calculate plan score, which I thought we implemented. Maybe we just didn't export it. We did. Calculate plan score. We need to give it the frozen state. Oh, I see. Because this is expecting the. Oh dear. Yeah, because calculate plan score suddenly expects. It expects the score, right? And how is it here? Calculate plan score. Okay, because I can just pass it like this, while the other one can be passed like that. Huh. Very interesting. Never thought about it. So here, our calculated plan score, it takes the score, right? Because that's what it's defined on, and the frozen state. So if we're gonna do this, planner.score, the calculate plan score, we kind of already injected the first score into it, but the rest is not injected yet. So I guess we would need to do something like, what is it? Plan frozen state, and do we define it? But one was like that, but the other one's like something else, and we just do plan. And I guess we need sugar for that. Sugar. It's not gonna work. I mean, it's not complaining here, so that's interesting. There's no way that's gonna work. Let's just make that a little bit nicer looking. If it's possible to format like that. If it is, then I'm happy. Builds and... Oh. What the hell? It works. Why does it work randomly? What the hell? I expected more problems. So right now, conflicting, we have just a very small number. So as we're going, we slowed down a lot. We're in a debug. But if we look here, the memory usage is not NimSuggest. Where is it even? Lead calendar, 123 megabytes. While we're chewing through all this. Let's stop. And let's run it in release mode. Did I run in release mode? Run, release. Oh gosh, that's like extra slow. But we're using very little RAM, that's for sure. I wonder if this shuffling and then reversing of the list and a few other operations are just completely slowing it down. It'll be nice to have like a heat map of which parts of code are going slowly or whatever. I mean, by the way, it's still pretty fast. I don't mind it. So yeah, that works so far. So if that works, we can just implement the last bit, which will be right here. Where is it? We don't need that. We don't need this whole project. In our program, basically, at the end, after we complete everything, yeah, at the end, we basically say, hey, scoring. We reshuffle everything, we score everything, and select few best plans, and that's it. So yeah, let's do that then. And our lead calendar, which is squiggly red everything. Let's do echo scoring. Oh, okay, that's gonna be simple. It's gonna write itself for me. So yeah, we basically want the resulting plans. Okay, so resultant. What is that? Resulting plans. Okay. So let's get those in the planner. Did I put the resulting plans somewhere here? Resulting. No. Okay. So at the end, we're just gonna add proc resulting plans. So it'll be just a sequence of frozen states. And all it does really, where is it? Here. It just combines the two and that's it. So will be result is planner valid plans, and then we're gonna do result, append the conflicting plans. I mean, if valid plans is not 0, just return. This way we just ignore the conflicted plans, but if not, just do that and that's it. Again, through much less code than Nim. So we get the resulting plans, hopefully. And after that, we want to reshuffle them. So we do resulting plans shuffle. So again, we need to get the random. And I don't think we need to change anything because we already called it in other spot. Import standard random. Okay. So we've got that thing. Weird, whatever. And then we'll basically select the best plans. And that should be relatively simple as well. So we'll be going over them. I don't think so. Let best plans. And we go through those resulting plans and select best. And select best will be, I believe, in planners or in score. Planner, score? Where the hell do we have select best? Planner. So we have access to planner. Perfect. Okay. Select best. And if that's the case, we just give it target count of 10. We want 10 best results. And we just tell it, use the calculate plan score. And we just need to do it this weird way again, I believe. Plan frozen state. Yeah. Something like this. And that should return us the list of best plans. So after that, we just want to do, just print it out nicely. Plan index 0. Worst score is that. Basically, for each plan, we want to calculate the score again. I know. And what else? If plan score is worse than that score, I'm just doing a little calculation. Okay. And plan index increase, and they're gonna print out, hey, we're printing the plan number this is the score. Which again looks, there's something wrong here. And then we just need to implement present the list. And that will be the last thing that we need to implement. And that's for the frozen state. So let's do that. Proc present as list. And we're gonna just take the state from state. We give it a list of all the names of the agents and available combinations per agent, all that stuff. So this uses string builder. We won't be using string builder. We're just gonna append to the return, the result, right? So basically states or states, let states will be state dot get state per agent. We have get state per agent. Not here. Ooh. Get state per agent. Huh. Sure. Proc get state per agent. And we just give it combinations per agent. Okay, sure. So let's see if this is implemented correctly. That doesn't look good. So basically, let agent count will be this, right? Which is extracted. Then state IDs, we just extracted using this guy. And then basically, if agent count is not state ID's length, we just need to throw that, hey, we have a problem here. And then result is basically a new sequence of booleans. Just make sure that it has proper count. And then basically for each agent, we just assign the thing. So combinations per agent, we get the agents, so we have combinations. And state IDs, yep. And return, and that's it. So we've got that guy. So I can continue here. Now for each week, for a week from 1 to state's length, like equals. And then we basically do not echo, we do the I mean, we could just echo, right? Hell yeah, we're just gonna echo. So echo that it's what the hell? Echo week ID and colon. And then what we're gonna do is basically assign names, and we're just gonna iterate over those names and then print them out. So basically, for each agent and those names. So states agent, week ID. Okay, so it's assigned. Basically add the name of the agent there. Okay. And after we do all that, we will simply join them. Yep, print it out. And echo. Wait, each echo will be separate line, right? Ugh. Yeah, let's not echo. Let's do result. Add that. And here we're gonna do result. Append that. And then result. Append new line. Okay. And that should be it. The only thing is that we need to do make it in, string. Okay, kind of ugly. And we need string utils. Be able to join. Okay. That's good. That should be enough to present it as a list, right? Hopefully. So back there. We're basically in that. Print as a list and echo. Yeah, new line, whatever. Let's see where the errors are. Okay, now we just need sugar up here so that we can use our lambda looking things. And next error is a declared identifier frozen state. Really, I don't import it? No, I don't. Import frozen state. And then undeclared field score. I don't export the score. Where is it? Yes, I don't export the score. Fixed. Gosh, this is going fast. Getting better at it. Attempting call undeclared routine. Calculate plan score. Okay. Calculate plan score. And why is that? Calculate plan score. In our score, we have calculate plan score, and we just give it a plan. Oops. Come on. So why does it complain that does not exist? So we have the planner. We were able to get the score out of it. I mean, we should be able to. And we should be able to call the calculate score on it, giving it the plan, which is the frozen state. Let's make sure I have the same calculate plan score. Paste it here. Yeah, it's the same thing. Okay, so that's an interesting error that persists. We have still the planner, right? So that shouldn't be a problem. I wonder if it's a problem because it's inside here or something. But no, it shouldn't be. It's just global and stuff. Do I need to bring import score? Will that fix it? Yes, that fixed it. Okay. I guessed correctly. All right, and this will just start chugging, I guess. Oh wow, run debug is real slow. Wow. I guess calculating the scores really slowed it down, huh? So, okay. Let's simplify it a little bit. Let's remove that guy here. And let's let it run on release, and we should get results, or at least get the results. Okay, wow, we already printed out, and we got only one. Where's fatal error? Okay. Okay, so let's run it again, but on debug to get the error. Scoring and frozen state nim 62. And here, present as a list, right? It couldn't print it. Why is that? Okay, so we're just going through the list in the wrong way. Let me compare it with this here. Present as list. So here we have agent ID less than the name's length. Okay, that's all good. Agent and week ID. And week goes from 1 to selections per week length. Huh. So be state dot selections per week dot length. That's the difference. Let's try to run it again. And maybe it's gonna work this time. Scoring. Oh yeah, it printed out 10 plans. Look at that. We have it working. So if I'm gonna run it as a release, it's gonna be like in an instant. Bam. There we go. We're limited by printing the plan out. So there we go. It ran 511,000 iterations. Found 158,816 valid plans. It didn't even go through one iteration of cleaning up. And we should have those in relatively random variants. And all the scoring tries to make sure that we have kind of even number of people in each, inside each week. So it's not like, oh, week 1, 2, and 3 will be 2 people, and the other one will be 7 and 8 or something. Tries to keep it even. So yeah, hey, we've got it done in NIM. 1-to-1 feature complete with C#. Other than logging of time. So yeah, I'm very excited. Uses roughly the same amount of RAM. So before I end the stream, maybe I'll share the next step, because this is not the end of this piece of software. So the thing is that the idea for that started when, my wife needs that for planning at work. It just would simplify if she would be able to put in the month, which is, which will calculate how many weeks, who she's working with, and, when they're not available. And it would just work out and find decent plan that she can just glance through, verify with others, and just have it done, in 2 minutes rather than in, 15 minutes, depending on how complex people's schedules are. Because sometimes it gets tricky, like puzzle work, and, it's just waste of time. So the idea is that I will be building a little browser extension for her so that she can have a little interface in the browser and bam, 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 done. But the thing is that there are a few ways I could attach this whole, this working thing. Right now it's just a random, application that you need to edit code. You could make it a console application and whatnot. But I want it to be 100% web-based, okay? So this will run in a browser. And there are two approaches to that. One would be to take NIM and compile it down to JavaScript, something that's apparently possible. The other approach, it would be to compile it to WASM and just put in a, WebAssembly binary and just attach it like that and run it, which would probably way better performance than if running it as pure JavaScript. At the same time, I feel like a little bit more complex because I never compiled anything to WebAssembly. So I would like to explore both of those approaches. I don't know if I'll be able to find how to easily compile NIM to WebAssembly, but I know that it would be very easy with C#. Nimaoth on Twitch is saying that NIM's JavaScript backend doesn't generate the fastest JavaScript. Yeah, that's what I would expect. Yeah, so, but I would like to try it. I would like to see what happens and how to, make it work in the browser, because, the whole idea of this channel here is me having opportunities to learn things that I often wouldn't be bothered even trying because, it's futile. But if I could figure out how to compile NIM to JavaScript, then, hey, that could be useful. I could make probably some tedious code just quicker to generate or something. Niamouth says for WASM you can use mscripten or nvim, LLVM backend for NIM. Huh. Okay. Cool. So, yeah, I guess I should try several things. And Beef is back, and he says on YouTube probably can do NIM.js or, whoa, okay, danger, and run it in Node.js right now. Huh, let's try it. If we have a command with danger in it, I'm definitely gonna run it. What the hell? Go away. Give me normal terminal. NIM.js -r the danger. By the way, it looks like we have first usage of our chat that we made on the stream. How did I put in that letter? Command expects the file name. Oh, let's give it, where is it? Leadcalendar.nim. Leadcalendar.nim. Ah. Okay. That's new. We tried. So yeah, this is the first time actually we have a proper usage of the new overlay that I'm continuing building on Wednesdays, so that we can have YouTube chat talking with Twitch chat, which is awesome. Oh yeah, you're right. To the SRC. Oh geez, not EXC. NEM. Sorry, I'm being dumb. Okay, cannot mix big int and other types. Use explicit conversions. Okay. Oh. Okay, this is where we're getting into those quirks of probably dealing with different kind of integers. Not sure. That's, I haven't read anything about how JavaScript works with NIM yet. I just know it has some limitations when it comes to types. So that will be probably interesting. Does it give us where that thing is? Lead counter.js. Oh yeah, that will be very readable. Yeah, it just gives us JS, unfortunately. Too bad. Remove danger. That's a fun thing to say. Whoa! What? Don't tell me that ran JavaScript. Because that's faster than pure NIM on release. Okay, so it worked without the danger, but are you sure this runs on actual JS? Either ubeef or Nimouth? Nimouth? I don't know how to pronounce it. It's challenging. Let's modify the code to actually be... It does, but it might be calling the exe. If I'm gonna remove the exe, because we have lead counter. If I'll run it again, let me just decrease it because it's just massive. Run it again. Yeah, it's going fast. If I'm going to introduce the state that... Wait. Lead counter here. The state that causes it to go through 360 million combinations. How fast is it gonna go? Okay, it's going pretty slowly. And what's the usage? Do I get something in like RAM usage or something? Because that's very interesting. Code exe? Node.js. It looks like it's running straight from Visual Studio Code. 4 gigabytes? Okay, it's at 4 gigabytes. So that's the bad part, because this code should run at 150 megabytes. So Beef says there should be a JavaScript you can call with Node.js. Okay, we're going to do that. And Nimouth says it should be you can remove the -r and run the generated code JS directly. So let's do that. So we can see that we have inside the source file. Okay, so we have the calendar.js. So node lead calendar.js. That's how it works. Yeah, wow, okay. That's it. Can I do bun lead calendar.js? Yes, we can. Bun works with that too. Awesome. Wow, this is way simpler than I expected it to end up being. Wow. So yeah, we have a JavaScript, which is... I must say, I haven't seen JavaScript like that before. Huh. Set constructor, so this is just a bunch of predefined stuff. Gosh, this could be minimized. Minified a lot. Yeah. Okay, apply combination. State combination. Huh. F line. So it just adds a bunch of lines for debugging. Wow, okay. Yeah, debug build, dash release, danger removes a lot. Okay, I see. So I would be able to do R the release. Okay, let's do that. Okay. Okay. And suddenly the JavaScript is much smaller. Okay, cool. And if I run a bun, it should be, yeah, it's not drastically faster, but you can see how quickly it just jumps from next to another one. If I'm gonna run nym in release mode, it's faster, but it's not that crazy faster, huh? So to compare it to now to C#, I need to do the thing that, the one little thing, basically re-implement the metrics. So we can do that quickly. I think it's gonna be relatively fast to re-implement that, okay? So the whole thing here, we can just clean it all up because this is a mess. We'll just, the only thing we need is this file. So we have has unavoidable conflicts and iterations per message, and I was using a stopwatch here and list of measurements. So we're just gonna make a var measurements, okay, and not doing it like that. I guess these will be floats. Okay, so this is where we will be storing the measurements of how many milliseconds we basically run through. And basically before the thing, we need to start measuring, and after that, we need to finish measuring. So I think we can use times. I used that before. Yep. Beef is already on it. But I know that this nym code can be improved a lot. That's the thing. I am sure that I just wrote shit in nym code. Wait. Okay, times, yeah. So, gosh, I'm getting confused. So start will be CPU time, but the thing is that I actually usually do that inside here. Wait, do I? Yeah. So we basically do this, and basically every, in this case, million iterations. Come on. Var start, and CPU time returns float, I guess. Yeah, it returns float. Perfect. So we start it, and then after the things, we stop it. So I can basically do the same thing with CPU times. But we'll include the limit plans inside of it, okay? So we'll just do let elapsed is CPU time, and is this, and what is the CPU time? Is it milliseconds, or what's the unit of that? Oh, it was you, the drunken, that you posted the standard times, the CPU time. Thank you. What is the unit of CPU time? Run current process and seconds. Okay, so this is seconds. So basically measurements add elapsed, and we're gonna divide it by 1000 so that we have a similar result, okay? Okay, and we keep going, we keep going, we keep going. The only thing we need to do is also set the start initially to be already CPU time, okay? And am I doing that here? When I have the stopwatch, I need to start it here so that we have the same thing. But no, first iteration will be divisible by that, so we don't need to. Okay. Cool. So now we just need to print it all. So the way we had it printed was down here. So finished after data iterations, print stats, and then we're just calculating a little bit. So we're gonna do let average. I don't think we can just call average on something. Let me look if we have something like average. Yes, you are correct. Nimouth. You switch from Twitch to YouTube. Interesting. But in the meantime, we don't have average here. AVG. Mean. That will have used. Thank you. Oh, this is actually like the most talking I ever had, so I guess I need to start streaming at 4 a.m. Thank you, Beef. Stats, and this would be mean, and yep. Okay, so we've got mean for our average. Then we're gonna do echo. Average time per that many iterations is that. Don't care about printing it out nicely now. It's just good. Let's just fix those milliseconds. Times 1000. There we go. Next thing will be total. Okay, so we just sum. Let total. Come on. We have sum. Hopefully. Don't know. We don't have sum. Sum. Math. Okay, this one is random in math. Okay. Come on. How many modules do I need to import? Okay, so we have sum, and we can print it out the same way. Echo total time is that much, and then we basically have the standard deviation. Oh geez. Okay. Let's standard deviation. And okay, we have some math here. Come here to see code. About to get demonstration for Nem kicking the C# ass. Okay. We'll see. So let's just do the same thing. Oh gosh, math. Square root. This is another part that I haven't done much with. So this is gonna be painful. Sorry about that. So we have just squirt. Okay. So we can just do squirt. And we're just gonna do measurements average. So AVG. Wait, average of is the average of a sequence of double values that are obtained by invoking transform function. Okay, so yeah, this is link for you. This is fun. So yeah, let's do that in a different way. So we do measurements dot map it, all right? And what we're doing here will be basically it minus the average and this whole thing to the power of 2. So I'm gonna go lazy way. There we go. And the result of it, we need to do mean. Okay. And then square root of that. Okay. Which means I could just do this. Gosh, this is hard to read. And for that, we need, what the hell was it? String utils. Sequence utils. Oof. Hopefully that's correct. I mean, why do I bother with start the deviation? Let's scrap the deviations, because that's pointless. It just has hiccups. I'm wasting time. Everyone's time. Okay, so what did I just delete? Not iteration average. I want iteration average. So we do let iteration average and bam. And this should be, well, where'd that come from? Times million to get nanoseconds. Okay. Is that it? Might be it. It just, that symbol requires initialization. Iteration dot float. Okay, now we're good. So let's run it on something fast to see. Oh, I'm probably gonna get an error, right? Because I needed to fix that quickly at some point. When we stopped at the stopwatch and because I recall I had a problem with this thing here for some reason. Let's try to run it and see what happens. There'll be an error, right? Oh no, there was no error. So we got average time per Dotman iteration is 0 because we start from 0 and that's it. So let's do it like this. We're gonna do 5 and just gonna remove those guys temporarily. I just want to see if several iterations will result in something. Again, I removed too much. Because I know that the first iteration doesn't count time correctly right now. Okay, we got some values. Iteration that much. That many nanoseconds per iteration. Interesting. So that's larger than in some earlier versions in C#, but that was before we had the this whole stats and stuff. So let me close Spotify and other weird things that I have. We don't need this guy running. We don't need a browser running. At least that one, nor this. So, yeah. we can just run it, right? So let's run it in nim release. There we go. That's gonna take a while. But we should have like no problems with anything. Just keep in mind that I'm also recording right now, so recording and live streaming to 2 streaming services. So it's a little bit slower, I guess. I don't know. So we are at 45. We'll go to 360. So it's gonna take a while. But at least we'll have enough data to get like meaningful average. Yeah, it keeps all the conflicts that it generates down, which is awesome. So was it you're all somewhere where it's morning, or like by that time it's probably closing in on noontime? Or is here somebody that's more from the US area that it's 4 a.m.? Okay, 185. This is going slower than yesterday, I remember. But I guess that whole scoring slowed it down drastically, but removed so much from the usage of CPU. Huh. It's late afternoon. Okay. Interesting. So you've got 3 time zones, I guess. Okay, 240. We have just 120 to go. Something tells me that shuffle is just extra slow, and the reverse is also not the greatest. Maybe their implementation of reverse is bad or something? But it's such a small reverse, so I don't know. Something is slowing down a lot. And I wonder what will be the comparison between also NIM and C# when they are both running as multi-threaded. Okay. You're there. And done. Okay. Got some plans. So let's write it down in the trusty little spreadsheet. Okay. We're gonna. Got it. NIM release. We do. What is it? Average time is 618.7. Okay, for the wait, what? Huh. It's very interesting because it kind of this number and that number is so close, huh? So let's do average iteration time. Okay, I'll keep that. Average iteration time will be 618.13 whatever nanoseconds. Okay, and now this is stopped. I'm gonna get to this guy. The Drunken says it's weird because as I'm learning them, I have been looking for sorting algorithms, stuff like quicksort, bubble sort, insertion sort, and whatever. Everything I read says quicksort should be faster, but all my testing shows insertion sort to be the fastest. Interesting. As far as I know, they all have their strengths and weaknesses depending on not only how large is your data set, but also how random it is. Because you have some searches that are really fast on like total random data, some are fast on, let's say, semi-sorted data or something like that. It impacts so much. Okay, so we've got that. So I will need to run the project on .NET, but I don't want to run it in the IDE here because that IDE will be tracking the memory usage and everything and slowing it all down. So let me just grab a ChatGPT. How can I run a .NET application using the .NET command line tool? I want to run compile and run it in release mode. Okay. Compile. Build it and run it. Oh, insert sort has been stupidly faster, 22 seconds for the other sort versus 0.05 seconds for insertion sort. Huh. Interesting. What is chat saying? .NET, your project... Oh. What? Navigate to the project, build a project, configuration release, and this. Okay, we're gonna do that. So let's close. Let's just make sure that we have the same setup. Okay, the same thing, same number of guys. 1 million. Stopwatches, everything is in the same order. Yes, and yes. Okay, this should be exactly the same. So I'm gonna close it and let's just get to a terminal. Where the hell do I have it? This will be lead calendar. Lead calendar. Okay, and I'm in the project. Okay, so .NET build configuration release. Okay, build succeeded. So we just do instead of build, run. Okay. And let's see if we're gonna get any kind of difference. Okay, that looks very similar. This will be a close tie. Which at the same time, if that's gonna be a close tie, I'll be my mind will be blown. Because C# is, you know, interpreted and stuff, so interesting. And what if we would compile C# to what do we call it? To an actual exe, because you can use ahead of time compilation now in C#. I'm gonna try that. I'm really curious. But the fact is that I know a little bit more about C Sharp, and therefore I was able to, I guess, optimize it for how it manages the data. And NIM, everything is just using sequences. In one spot, we have a dequeue. And I have no idea how performant those are or how to use them good or, not good. I mean, how to use them well. Does it work run faster? I think it runs faster. Hmm. We're nearly there. Just 100 million more. After that, we can run a test where they are not using the sorting to reduce RAM usage. And I think that would give NIM an edge. Okay. Come on. Got the results. Oof. Ouch. Where's the thing? So .NET release average iteration time. I mean, where is it? 446.62 nanoseconds. Okay, so that's not a result I expected actually at the end of the day. So let's give NIM a situation where we don't call the one thing, which is it limit plans, because something tells me that's the main limiting factor. Okay. So if I'm gonna run it now in release mode, holy macaroni, that is a little bit faster. But at the same time, the memory usage is going up. As in, we're using 10 gig of RAM, which is not bad actually. Hmm. Okay, this is better. NIM, no, whatever call it, no limit. 141.32 nanoseconds. Wow, that was fast. C Sharp won't get close to that. There's no way C Sharp will get close to that. I'm just gonna remove the limit plans, and I already know that exit, and the moment I rebuild it, the moment I run it, it will be much slower. Oh no, what the hell? That's fast too. we're getting some wars going on here. But I can already see that C Sharp is starting to chug at some points. I guess GC is kicking in. And wow, was using so much more RAM. Hell, why is this one still going? Nim just hung. Let me stop the other one because Nim just straight up hung on the scoring. It just stopped working. What the hell? So let's stop this guy because we're just not having proper results. Very interesting. It just stopped here and was just hanging this whole time at 28 gigs usage. Very odd. I guess it didn't like. Oh, it probably because it needed to go through scoring of all those. There was probably something like how many? 291 million plans that they needed to go and score, and that scoring is the thing that was really slow. So there we go. It's not liking it. So now we can go to .NET Run. And we'll see if .NET is going to hang after at the scoring part too. But yeah, Nim had a usage of 28 gigs of RAM for that part of code. And I don't know if it's visible on the stream, but C# sometimes just stops for a moment, like now. Must be, garbage collection. Something tells me Nim has much more lightweight garbage collection than C#. Come on, C# can do it. It will be 250 nanoseconds per iteration or something. Okay. I was close. 237.00. Okay, and I'll be .NET no limit. So I want to try one more thing. If you have any kind of way for me to run the Nim program that I know makes it faster or something, let me know. I would like to try it. I want to use a head of compilation in the .NET C# AOT. So publish also dynamic code analysis. RID, what the hell? So let me just go to the project and search for that thing. Come on, writer. Oh, this is still scoring. So the scoring just takes so much. Huh. It's better to put this setting in the project file rather than passing it to the command line. Okay. So I think I might already have it or something. Come on, where's writer? Project. Publish AOT true. Okay, good. So we've got that. Publish the app for a specific runtime identifier using this and that. The following example publishes the app Windows as native AOT application on the machine with the required prerequisite installed. So we're gonna just do that. Okay. Okay. Let's try that then. We're gonna publish as this. What is going to happen? Okay. Leaker bin release .NET 8. So bin release net 8 when this publish. What do we have here? We have actual exe. Oh, whatever. I don't know what the size is. What's the size of this thing? Can I do Explorer? Oh yeah, that works. Oh, the whole thing compiled to 1.6 kilobytes in size. Holy moly, that's small. So let's run lead calendar here. It's slowing down. I'm gonna check the nym exe. The thing is that this compiled to the C# compiled to the exe, but it still has some dependencies on stuff installed from Windows. That's why the executable is so small. While nym, I presume, is totally self-contained. Okay, this is going pretty fast. There was a big pause there. Not good. Okay, roughly the same thing. 227. So nym is still faster. Okay, so nym wins. Where do I have this thing? Switch to here, and we put in 227.59, so we .NET AOT. Okay. So we didn't gain much, unfortunately. Cool. So nym exe, let's see. I should be able to just get here, right? Reveal and explore or something. There we go. 332 kilobytes. Huh. Not bad, to be honest. That's tiny. Cool. To be honest, this difference here, I mean, nym is, what is the percentage here? This divided by that. Of course. Wait, which one divided by what? Come on. This divided by that. So, okay, so nym is 1.6 times faster than .NET. I guess it's adequate, I'd say, because it's not like crazy on a level of going, 2-3 times faster, which would be ridiculous. But at the same time, it's, it's not so close that you will wonder like, I'm not gonna get a benefit from using that different language. Cool. Okay, so that's that. This was just surprising. Oh yeah, so this was with the actual. So .NET was much better in case of analyzing the scoring, and something tells me there are just few little things there where we could improve it. But it's 4:30 here. My wife is gonna kill me because she doesn't like when I come to bed like a bit late, because then I can't live the next day. But yeah, that's that. So I'm gonna push both updates now so that we have the same code in both, so you can tinker on your own to maybe find some kind of interesting speed ups. So let's see. State combination score, I just remove a bunch of stuff, and we just this and that. Okay. Let me update C# project. And then we're gonna basically commit the whole, if just not the exe. We don't want to commit that part. Bunch of name, not the JS. So we're gonna do port to nim. I'm gonna push it, and where you can find it. Gosh, this is so gigantic. You can basically go to github.com. Okay. You can search for Xconti, and okay, what the hell? What are those? Sure. You can go search for user Xconti, and there'll be lead-calendar. I'm gonna put a link here. The link is already in YouTube description, by the way. So link here and link here. Play around with it. And yeah, if you want to, put some pull requests or whatever issues regarding some performance-wise things, it will be very welcome, because it's an opportunity for me and probably other people to learn how we can optimize it. And if we could get some interesting things there, I wouldn't mind showing it off on the stream to basically, update like, hey, there's this cool thing or whatever. So yeah, that's that. And I'm gonna close that, and I'm gonna close that, and that, and that, and that. And I want to thank everyone for watching. It's fun to have some company. I wish I could just stream at this time on a regular basis, but yeah, unfortunately. And I think it's this. There was some kind of survey I read at some point, and I thought, was it NIM survey or whatever? Basically, the average NIM developer is from Europe and has at least 10 years of experience in programming. So far from what I see, that's the thing. So again, thank you for watching, and I hope to see you next time. Oh, one thing, I won't be streaming throughout, normal days of the week for, next week, because I have a business trip. So most likely I won't be able to stream. So that's a heads up. So again, thank you for watching, and consider subscribing, consider liking the video. You can follow me on Twitch as well if you prefer that, and all the goodies. And to the next time. See you.